음. students. Good afternoon, students. Okay, can you hear me clearly? Okay, yes. So let us start with the today's class. Okay. So do you remember whatever we had discussed in the previous class? Yes. So I hope you remember whatever was done in the previous class. We were discussing initially about the sequences and all that. Okay. So we are doing summation. Yes, I know. We were first discussing about the sequence, and then we had discussed what is a series, and then I had told you that in order to find the sum of the given sequence, we can write in short using that summation notation. And I had given you, I think, 2 3 problems to try on your own, whether it is possible for you to do, isn't it? Yes or no? Did I give you that problem, those 3 problems? Okay, yes. So whether you were able to do it. Okay, you were able to do it. So it was the easiest one, I hope. Okay. So after that, today we will be continuing with the arithmetic progression. Okay. Asha, yes, yesterday I was not able to take up classes because I was not well. So there was no maths class yesterday. I couldn't adjust with any this one. So that's the reason. Uh, so today I am continuing with that. Okay, is it fine? Okay, yes. So that's it. So now let us continue with this one classes today. So let us start. So I'll start from wherever we have stopped in the last class. Okay, is it fine? We'll start with that. So let us start with that from wherever we have left. Okay, yes. So okay, yes. So I'm better today. Thank you for your concern, students. Yes. Okay. Yes. So now we were in that. Yes, here. Correct. We were here, and I had asked you to. Yes or no? I had asked you to complete this problem. Yes. Am I correct? Okay, so we had done that. So let us see today how we will be able to do it. It's very simple. So let me do that first for you here. So I had asked you to find the sum of 4 terms only. So if I ask you to do that, okay, then in that case here you will be able to write the first term as take k equal to 1. So the first term will be here k is equal to 1 will give you 5. Then second term 5 k is equal to 2 will give you 10. This is k equal to 2. And then k equal to 3 will give you 15. And then finally k equal to 4 will give you 20 here. So to all together this much is 30 plus 20 is equal to 50. This is what we have. So there is one more here. The second one, I'll do that a little later, students. 1 minute. I'll just divide the space here so that we can have it. So the next problem was I is equal to 0 to 3, 2i plus 1. So what we have to do, we have to take, find the sum of first 3 terms. So we have to take from I is equal to 0 to almost 3. So if you take I is equal to 0, then it will be 2 into 0 plus 1, which is 1. So I is equal to 1 if you take, 2 into 1 will be 2, 2, 2 plus 1, correct? So you get 3. Then here you have I is equal to 2. Then finally I is equal to 3. I is equal to 2 will give you 4 plus 1, which is 5. So again, finally 2 3s are 6 plus 1, 7. So this is what you get. I think you have got the answer as 16. Is it correct? Okay, I hope you have got that answer. So the next one is factorial, right? It is k is equal to 0 to 4. Then it is 5 by k factorial, right? So here if you take that, it will be like somewhat like this. It will be 5 by, first is 0 factorial. I have told you 0 factorial is 1, and then it will be 5 by 1 factorial plus 5 by 2 factorial plus 5 by 3 factorial and then 5 by 4 factorial. You have to finish this off. You will get the required answer. You will get here 5, and then this is 5 because 1 factorial is 1 itself. This is 5 by 2 because 2 factorial is that, and here it is 5 by 6 because 3 factorial is 6, and here it is 5 by, it is 4 into 3 into 1, that is 24. So take a LCM, whatever answer you will get, that will be the final one. Is it okay? Fine. I hope you have understood this one clearly. Is it okay, students? Okay, yes. So now we'll move on to the next part, that is the next concept. Next, we will be moving on to the arithmetic sequence. So somebody was asking me other day, who has found the arithmetic sequence? Actually, there was a person who was given, actually it was in the class. The class teacher wanted to little bit relax. So what she had given the students work is to add the numbers from 1 to 100, add natural numbers from 1 to 100. So that, like, small kids means they are not even 10 or something like that. They were somewhere there very close to a very young age. They'll take some time, isn't it? Yes or no? Because they are just learning the addition and subtraction in the lower classes, and they are just coming to the some fourth standard, something like that. It is around 10 years. Okay. So what is that they have done is, this one, the teacher has asked the students to find the sum of first 100 natural numbers. So there was one boy in that class. So what he did is, he took that numbers, and what he has done is, suppose this is one, this thing, that 1, 2, 3, and 4, like that. It just continued. Okay, like this, it continued up to 100. So he was asked to find the sum of this. So what he did is, he just wrote like this, up to 100. Again, what he has done is, he has reversed it like this, 99, 98, and so on up to 1. And what happens if he does this? There will be 101, 101, 101, and so on up to 101. How many 100 times it will come? But he doesn't need so many 100 ones, because he was asked to find the sum only once. So what he does is, he adds all these 101, 100 into 101, he adds. Okay. So what he will get? He will get it as, what is it? He will get it like this, 10,100, correct? But his answer contains these twice. So what he does is, he divides this by 2. So you can get the answer as 5. Then what is that? This is 5 and then 0. Then you have to take 5 together. So he will get the answer like this. So his answer was this. So is it correct? Anybody can tell me whether it is correct, whatever he has got answer? Something like this he has done. So this is where the people started observing a particular kind of pattern among these numbers. And that is nothing but, that is the arithmetic sequence, or what you call it as arithmetic progression. And the person who had done this was Gauss, who is a German mathematician, as well as he is into physics also. Okay, so that is why he was actually, this was named after, like, it is a whenever we discuss about arithmetic sequence, this story which comes the first. Okay, so the entire derivation of the sum of n terms of the given AP is also discussed under this. Is it okay? Yes. So this is where they had taken AP. Okay, this is the original place from where the AP had been discovered. After that, many people have used. They had used these kind of numbers before, but what happened is, after that they were not able to. Okay, yes, so correct. Yes, course. Okay, somebody, most of them were able to. Yes, so most of them were able to do it. Okay, yes, so that's it. Yes, so okay, yes, good. Yes, correct. Okay, it was a punishment for him. Okay, yes. Yes, says punishment to M. Goss. Yes, yeah. Some stories say that even it was a punishment to him. But anyhow, that was the place where they were able to discover something new. Okay, before that it was not like that. Okay, yes. So that's it. So this is about the story where they had come across new concept. But after that, it just gets developed on its own. So they were able to find different concepts related to that, and all that happened. So now we have the arithmetic progression. So let us start with the arithmetic progression. As I said, see, one thing you have to understand when it comes to the arithmetic progression here, Okay, you have to remember one thing. When it comes to the arithmetic progression, we will have two things which you have to remember. Okay, that is nothing but one is the nth term of the given this one AP, another one is the sum of first n terms of an AP. So we will be discussing both the things, and we will see how we have derived that formula also. Okay, so let us start with that. So first thing is, let me take one simple AP, students. So just think that you are given one simple AP which is like this. Maybe I can just take where the difference is 2, like this. Is it fine? Or you can take anything where the difference remains the common, correct? So that is what is AP. Now I didn't discuss the something up to, maybe we can go for 24. Just think that you are given, then this kind of AP is called as finite. Suppose if I don't have this term at all, it just continues after 16, then it becomes a infinite AP. Okay, so there are two things. So here it is a infinite AP, and if I write everything and without last term, if I just give that 3 dot, then it says it is an infinite AP. Okay, so this is what we have regarding the AP. AP is a one. We can say, suppose if you are saying sequence, then also it is correct. But remember, progression is a part of the sequence. There is nothing like that, many of the books they define it as progression. Okay, but there is nothing wrong if you say it is a sequence. But because what happens is, the first word arithmetic defines it, saying that it is only those sequences where you will be having only those kind of sequences whose consecutive terms will have a proper, or what we call it as common difference. Okay, so that common difference is denoted as D. This is a common difference. And the first term, as I have discussed in the previous class, it is denoted as A, and some of the books they denote it as A1 or T1, anything depending on what kind of books you refer. Okay, that is according to that you will have. And AN denotes the nth term. Okay, if it is the finite sequence, then AN may denote the last term also. And then there is something called as L, which is the last term, which is sometimes we will refer it as AN itself. Okay, these are closely related. N will be the last value, that's it. Then it is AN itself. Okay, then we have something called as SN, which denotes the sum of first n terms. Okay, these are the few things we will be discussing under this. So what is that first thing? First thing we will be discussing is n, that is nth term of AP. Nth term of AP. Now how do we write this? For that, let me take one example, whatever I had taken there: 2, 4, 6, 8, 10, and 12. Enough, I think. Okay, so let me see what is the common difference between them. I can observe that the common difference between them, that is 4 minus 2, or 6 minus 4, or that is equal to 8 minus 6. Like this it continues, and the common difference is 8. Correct? So I have the common difference 8, and I know that the first term is 2. So based on this, what I will try to do is, here I will try to write these numbers in terms of A and D. In that case, first term will be A itself because it is just 2. But second term, if you observe, 4 can be always written as 2 into 2, correct? So that is why what I can do is, now you may ask, why am I taking 2 into 2 only? The reason is I am trying to write it in terms of this A and T. That is the reason I'm doing this. Okay, so that is why this becomes 2 and 2. But 2 into 2 is nothing but 1, 2. If you take it as A, then, okay, one thing I'll tell you here. See, what I can do is, there are this one. I can write this into, but here what is the concept we have? We have the common difference as the concept. So if I write, it will not work for the common difference here. Into won't work. So what I can do is, instead of writing into here, what I can do is, I can just make it plus. What happens if I make it plus? Then the difference between these two terms remains the same. A is 2, right? So you can just check 2 plus 2 minus 2. So this cancels. Your answer is D, which is common difference. So that is why instead of writing into, I will write 2 plus 2. So then this becomes A plus D. And same way, you can write this one as 6 as, now you may ask, 6 how to write? What you can do is, 6 can be written as 2 plus 2 plus 2, where this if you take as A, then this can be written as, okay, you have D. If you take this as D, then this can be written as 2 times D, because 2 is added 2 times. So I can write it as 2 plus A plus 2D. Same way, the third, this one can be written as A plus 3D. It is written, 8 can be written as 2 plus 2 plus 2 plus 2, like this. So then this will be A plus 3D, like this. So this is what we have. So continue further. Next one will be A plus 4D. Like that, if you continue up to n terms, remember this was the first term, this was the second term, and this is the third, fourth, fifth. And then finally, when it comes to the nth term, it will be, for first term, no D at all. For second term, there is only one time D. For third term, there is only 2 times D. Fourth term has only 3 times D. So when it comes to the nth term, it should be 1 less than the n, that is n minus 1 into D. So this is what we have as the nth term of the AP. Okay. Okay. So is it clear to you now? Okay. Yes. Yes, see, there is a common difference. There is nothing like a rule that it should be a real numbers. There is possibilities. Okay, we can have some of the infinite series is not infinity. No, no, it is not. Okay, usually in the AP they will not ask you to find the sum of infinite series. Okay, there are different ways to do that. In the GP there is a separate formula to calculate the sum of infinite series. But when it comes to the this one, that is AP, we have the sum formula only to calculate the first n terms of this. Okay, it can be even a rational number. Yes, we can have complex numbers. There is a possibility, but usually they don't give you that kind of problem. But rational numbers 100%. Okay, yes. So that is what we have. Okay, yes. So yn minus 1. Okay, once again I'll repeat the same thing. Please, I'll try to get it. Okay, 1 minute. I'll just put it to the side. See, what I've done is I am trying to write. See, I know that A is 2. That is, here it is. A is 2 here, correct? And I know that common difference is also 2. So what is my aim is to write these numbers in terms of A and D. So that is why what I have done, A is 2 itself. So first thing, I'll just write it A. And next what I'm doing is I'm trying to write this 4 as, actually I can write it as 2 into 2, but the definition says that the difference should be common. So there is no product here. That is why what I have to do, instead of writing into, I'll be writing here plus. So then I can see there is 1, 2 and another 2. So I can replace it as one as A, another one as D. Like that you continue. So first term remains common, but what we can do, we can just go on increasing the D values here. So D value is like, you can see here, 6 can be written as 2 plus 2 plus 2, like this, where 2 is just A. After that, what we will do, the remaining two things, we can just take it as 2 times D, because this is added, 2 is added 2 times. So that can be written as 2 into D, like this. So that is how we continue further. And when it comes to the nth term, we write it as A plus n minus 1 into D. So this is what we have. So here, one thing you have to observe, when it comes to the first term, there is no D. And when it comes to the second term, there is only one D. When it comes to the third, there is only 2 times D. So same thing, if it comes to the nth term, there should be one less than that position. Suppose n is there, the one less than that position will be nothing but n minus 1. So that is why I have taken A plus n minus 1 into D when we generalize this. Is it okay now? I think some of you had this one problem with that understanding. So I think now it is clear. Okay. Ashay, yes, sometimes they will give you irrational numbers also. Okay. Yes. Okay, Shashank, why don't we take like that? The reason is, see, what is that it says? The definition of AP says, we just go on adding certain number, right? So what happens when, if you consider 2, to get the second term, they are adding that common difference 2 times. That is the reason we don't take 2a, 3a and all that. We can take, but when it comes to the this one, what is that? The definition of AP, it says that AP is that kind of sequence where the difference between the consecutive term remains the same, or we can say that difference is same throughout the series, so or the sequence what they give. So according to that, in order to get the second term, suppose you have 2 here, right? In order to get 6, you need to add that common difference twice to this. Or in simple words, if I have to get 8 here from this first term, then I need to add that common difference 3 times. That is the reason. Okay, yes. So that is the reason we don't take it. Is it okay? Okay, that's it. So this is about this one. Actually, see, Shashank, in here we don't have any formula to find the sum of infinite AP. We don't have it. It is there in GP. We have a particular formula, but we may use some other concepts and all, and we can try to find the sum. Okay, but when it comes to the AP doesn't have a particular formula there. Okay, is that okay? So that we will be dealing only with the things like, a finite AP, the first n terms, or they'll just tell you find the first n terms of find the sum of first 25 terms of the given AP. Even if it is infinite, they'll try to restrict themselves to the finite AP. Okay, yes. So there is no particular formula for that. Okay, yes. So that's it, I think. Okay. Yes, irrational numbers means yes, they may give you root 2 like that. Okay, yes. Okay, so that's it. Actually, Murali, there is some other concepts. We'll be discussing about that this one later on. Okay, actually, we have something called as advanced series and all that. Advanced studies there. That time I'll discuss about it. Okay, is it fine? Okay, yes. Infinite GP also we will be learning about the GP's derivation. Okay, so that time we will discuss, and I'll be discussing even about the binomial theorem. Now, for time being, I'll be just giving you the expansion of the binomial theorem, but later on when it comes to the last part of it, like where we will have a little bit of advanced problems and all, I'll be taking some problems from JE mains and all that. So I'll be doing that time. What we will do is we'll look into different kinds of series, students, then you will get a clear idea. So now I'll be just teaching you the very basic concepts of these things at because just you learn to solve how like few problems here. Okay, once that is done, then it will be easy for us to continue with the other advanced problems. Is it okay? Fine. Now shall we start with that? Okay. Yes. So Pratisha, that time only I'll be answering your question also. How to find the sum of infinite AP. Okay. There is a formula. We need to understand there are 3 different cases when the ratio is below less than this one, all that. Okay. Yes. Yes, I know I have to teach you combination for that, but then I'll be just giving you a brief idea about what is combination. Okay. So that's there. So this is the about the derivation. So I hope it is very clear to you what we have discussed. So in general, suppose I'll just write a brief this one about it. Okay. Suppose let me write down in brief. Suppose A is the first term. Okay. And then if you have D as the common difference and N as the number of terms, then according to that, an is nothing but a plus n minus 1 into d. So this is what we have. This is the formula to find nth term. Okay, so this is what we have. Is it okay now? Have you understood clearly what is this one nth term of a given AP? Okay, now we will see how to find the sum of first n terms only. Okay, first we will discuss only about this first n terms. So Sn also denotes the sum of first n terms. Okay, so what we do here is to find this. First thing, I hope you have noted down the students. Please remember here nth term, an is nth term, a is a first term, and d is a common difference, and n is a number of terms. Please write down that, because again I have to derive here the sum of first n terms. Again, this derivation just goes like, how the Gauss has taken that sum of natural numbers. So same concept, but what we will do is we will take the general idea of the AP and we prove this one formula here. Is it okay? Shall we start with that? Okay, Sn. We are going to find out what is the sum of first n terms. Okay, yes. So now let us start. Suppose you have an AP like this. A plus D, right? A plus 2D, as I said, A plus 3D. And then finally, just think that you have up to A plus n minus 1 into D. I've just taken the sum of the first n terms of an AP. Okay. So here, this is called as general form of an AP. Okay, this is called as general form of an AP. Okay, this is what we have. So once this is there here, please understand what we have to do is we have to add this. So what I'll do, Sn, I'll take the sum of first n terms. If I have to add, then it will be like this. A plus D, then A plus 2D, A plus 3D, and so on. Okay, if you want, you can add one more term here, A plus n minus 2 into D. The previous term will be n minus 2D, okay, comma. Then here you will have plus A plus n minus 2 into D plus A plus n minus 1 into D. This is what we do. First equation is that. So next what we have to do is, see, Sn remains same. You add the numbers from the beginning or the end. So the next, what is the next step is, we are going to write from the last. So then what we will get here is A plus n minus 1 into D remains as it is. Then A plus n minus 1 becomes here 2, because we are going for the previous term, and so on up to here we have A plus 3D, and then A plus 2D, A plus D, and then finally A. Right, this is what we have. This is equation 2. So this again, it is given, this derivation was given by Gauss here. That is how he has found the sum of natural numbers. That same concept has been continued now also. So you have to add 1 and 2. If you add 1 and 2, that will give you 2 Sn, because this LHS and LHS I'm adding, and RHS and RHS I'll be adding. Okay, please understand, this term, first term to the first term, we'll be adding like that, second term to the second term, and then finally I will not go for the other terms in between. Then what I'll do is last but one term to the last but one term of here, and the last term of this to the last term here. Okay, so that will be giving me here, please understand, A plus, okay, n minus 1 here, that is the first term, A plus, this is what you get, first one. Okay, plus, okay, let me take different colors, then you will get an idea. This one, it will be like this, A plus D here, second term, and then plus A plus n minus 2 into D, that is the second term. Next, go for the next last but one term, that is last but one term is A plus n minus 2 into D, plus here it is A plus D. Okay, finally when it comes to the last term here, okay, it is nothing but A plus n minus 1 into, okay, D plus finally A term. So now if you observe carefully these terms, if I add this 2, it will give me 2A plus n minus 1 into D. And when it comes here, if you add these two again, it will give you 2A plus, now please understand here, D terms I'll be adding together. So if I add D terms there, it is like this, D plus n minus 2 into D. Take D common, you will get it as 1 plus n minus 2 in, then you will get, if you add this, D into 1 minus 2 will give you n minus 1. So that will give you 2A n minus 1 into D. So same way you continue that, even this one, will give you 2a plus n minus 1 into d. Again, here also same thing, a with the a and d with the d. Okay, and here again last term, it is 2a plus n minus 1 into d. How many terms were there in this? There were n terms here. Okay, there are n terms. So I hope you remember there is something called as okay, yes. So okay, yes. Ketan, as we say, as you have told, telescopic series can be used when it comes to this one. What is that binomial concept? If you use, yes, there is something like that. Okay, we do. No, n is in general. We are taking n terms are there. Okay, yes. So a plus n minus. The reason why it is a plus n minus 2 is the previous term. Okay, it is the previous term's position. That is what is n minus 2. Okay, yes, so that's it. Yes, it's a derivation. I don't know. The derivation is like not that important, students. But if you have an idea, sometimes what happens is when we don't get any, any formula or something like that, this may be really, really helpful. Okay, other than that, it is fine. Okay, yes, so that's it. Next, we'll move on to this. So now please understand one important concept, students. See, suppose if I have 2 plus 2 plus 2, instead of adding this, I can write it actually as a product also. That is nothing but if I take 2 common, okay, then here this will become 2 into 3, 6. Same way here, there are n terms. So I know that this is common for everything. So that if I take common, then I'll remain with n there because there is, what is that? There are n ones. So that is nothing but just as this. Okay, instead of writing like this again and again, same thing, what I can do is, this is n times it is. So I can write it as n into 2a plus n minus 1 into d. And then this 2sn remains same. Bring it this side, you get Sn is equal to n by 2 2a plus n minus 1 into d. So this is what is the formula to find the sum of the this one AP. Okay, so n terms of first n terms of AP. Okay, I hope no doubt regarding this. Please understand, this is a concept we have used here. Okay, if 2 is repeated 3 times, I can write it as 3 into 2. That is 6. Okay, that is same. So same here also. I have 2a plus n minus 1 into d. I have up to n terms because I had started with the, how many terms? I had started with the here n terms. That is why we have it like this. So this is what is a derivation. Please understand. I hope it is clear. So shall we move on to the examples and all that? Okay, 1 minute. Okay, yes. Is it okay? Shall we move on to the next one then? This is the formula which is used when you don't know the last term. Okay, you just know that you have to find the sum of first n terms. So there is something else after this. I have given you actually that formula also, how it comes and all that. I have given a little bit of explanation, but I'll make it very clear now. So till here you finish it off. Is it okay? Shall we move on to the next concept then? Okay. So we got this now. Here, what was the formula? We got the formula as Sn is equal to n by 2 into 2a plus n minus 1 into d. So this is used when we don't know nth term. Okay, when we don't know. Okay, that time we will use. But suppose if you know nth term, okay, nth term is known to us. In that case, what happens is this formula can be split or rewritten as n by 2 remains as it is, but I'll split this 2a as a plus a. Then I can observe that this much is nothing but it is the an formula. So I can write it as a plus an. Okay, this is what we have. Is it okay? Fine. So this is what we have when you know the nth term. So this is another version of that formula. So these are the two versions we have. Okay, sometimes here instead of an, some books may give you a plus l. It is one and the same, because we will take this formula only when we know the nth term or the last term of the given sequence, if it is finite. Otherwise, if it is infinite, most of the time there will be like a nth term they'll give you. Okay, so that is what we have. So these are the derivations. Is it okay? Now shall we move on to the example parts of this? Okay, so now let us start with that. Okay, yes, so that's it. Yes, correct. Yes, so that's it. Shashank, I had taken a generalization of AP. I have not taken anything else. Okay. Yes. So generalization of the general term of the AP, that you should be in general this itself. Okay. It should be in AP itself. It is not the odd and even cases and all that we will discuss later on particularly. Okay. What happens to that? Okay. Yes. So now we'll move on to the next one. Okay. Yes. So this is about this problem. Okay, yes. So now we'll move on to the next one. So I wanted to show you that this one. So here, let us move on to the next one. So please write down those who didn't write down this. Some of the books, they even use TN as the notation. So it is one and the same. So I hope you have noted down. And then these are the examples we have. So shall we start with the first one then? Find the formula, okay, for the nth term of the arithmetic sequence whose common difference is 5 and the first term is -1. It's very simple. Okay, you can just note down the question, students, every question. Kindly note down all the questions and then we will solve this. It's very simple. Done? Shall we move on to the next one? Okay, yes. Yes, fine. You can write down every question, then you tell me the answers, students. Okay? Yes. Quickly, note down. Done? Okay, yes. So we'll move on to the next one. That is, we'll take whiteboard. That is better. Okay, yes. So the first problem was, we'll move on to the example part, students. Here, examples. The under that first problem was, they had given us common difference is 5 and the first term is -1. They are asking find the nth term. An, what is it? So in general, we don't know what is n. N will be n itself. So what we will do, we will take an is equal to, because we know the nth term formula is this, correct? So that is what we will do. We will take this and then we have an is equal to a plus n minus 1 into d. So a is -1 plus n we don't know. So keep as it is into common difference is 5. So now multiply this here. You will get the answer as -1 plus 5n minus 5. So when you add these two, plus 5 will remain here, 5n here, and then -6. So this is your answer. So first question is done. Is it okay? So the next question is, the second question was, they had given us A8 is, that is eighth term is 25 and the 12th term is 41. So write the first 4 terms, right? Isn't it? Yes or no? You remember what they had asked? They had asked us to find, we know 8th term is 25, 12th term is 41. Write the first 5 terms of the sequence. So you need to find out what is A as well as D to write the first 5 terms. Is it okay? So shall we go move on to this one? So we know what is A8. A8 is 25, correct? So A8 if I'm taking, now what I'll do is, in order to find A and D, I'll be writing these two in their general form. General form in the sense, I can use AN formula just like this. Okay, if I use AN formula, then it will be like this. N is equal to 8, right? So it will give you A8 is equal to A plus 8 minus 1 is 7. 7 into D. This is what we get. A12 again, it is nothing but again A plus 11, N is equal to 12 it is. So 11 D. This is what you get. Is that clear to you? So I'll be using these two equations to rewrite them like this. So I'll get from this first one, A plus 7D is equal to 25. First equation. And the second one, A plus 11D is equal to 41. Now you can see this is a linear equation in 2 variables. I'll be using elimination method. If you are interested to use any other method, you are most welcome to use those methods. It's your choice. Okay. So here A gets cancelled. 7 minus 11 will give you minus 4D is equal to minus. What is this will give you? What this will give you? This will give you 11 minus 5 is 6. And then here, what is it? 16. So this gets cancelled. D will be equal to 16 by 4. Answer is 4. D is 4. Now we have to find A value. So what we can do, we can go back to any one of this equation. You can name them as 1 and 2. You can go back to any of those equations. If you do that, you will get here as A into 7 into 4 is equal to 25. Or you will get it as A plus, okay, this will give you here a plus, I'll just not use that. 25, what is this? 28, right? So your answer is minus 3. Is it correct? A is minus 3, is it? Are you getting minus 3? I hope all of you got the answer, students. Okay, yes, minus 3. So we got the first term. So write the other terms. Okay, yes. Okay, yes. So what we have done is, Nihat, nothing else we have done. See, we are given A8 and A12. So what I did, I have substituted n equal to 8 in an formula and n is equal to 12 in an formula again. I get one equations. Using that, I have rewritten these two equations as A plus 7D is equal to 25 and A12, that is A plus 11D is equal to 41. Then I have used elimination method and I get D is equal to 4 first, and then I'll go back to equation 1 or 2 of your choice. Okay, you can use 2 or 1. I have used 1. So using that, I get A is equal to minus 3. And then once this is done, we have to go for the further this one. That is, we have to find the AP. So the terms of AP will be minus 3, plus 1, 5, like that. It just continues 9 and 13. Is it correct? All are getting the terms of AP. How do you get that? A. Second term is A plus D. So it is minus 3 plus 4. That is how you write it. Correct? I'll just, okay, let me erase this part. Then I can just tell you how is it calculated. Okay. So the calculation is like this. First term is A itself. A is minus 3. Second term is A plus D. That is minus 3 plus 4. Answer is 1. Sorry, plus 1 it is. Then A plus 2D it will be. Or you can even go for, suppose this is A2 and this is A3. Then you have one option is A plus 2D. Or you can even write it as A2 plus D. Okay. This is what you get. So according to that, your answer will be 1 plus 4. Answer is 5. So like this, you continue again. 5 plus 4 will be 9. Then 9 plus 4 will be 13. So this is your required AP. Okay, now we'll move on to the last AP. What they are asking is, they have given us, please understand the question for the last AP. Okay, they have given what is the value of n in the following expression. So what they have done is, you can see there are two things here, like up to n there is one sequence, then again it starts from n minus 1. You can take it other way around also, it is okay. So this is what we have, but they are telling these two when you add it will give you 289. If that is the case, then find what is the value of n. So now remember, since here it is sequence, n denotes actually the number of terms, correct? So it is that you have to get a positive integer. That much you have to keep in mind, because here n denotes the number of integer, number of terms. So you need to get that as a this one. Okay, so what we can do is, you can see there are two parts of this question. So we can divide this question into two parts. Till here we can take one AP. Okay, from here onwards we can take another AP. So the sum of two APs, if you add, then that will be equal to 289. That concept we will use and we will try to find out. Those who know how to get the sum of n positive integers, if you know that formula, you can use it. It's left to you. Okay, I will be deriving later on. Okay, I'll be doing that in this one. But now for time being, what we will do, we will divide this question into two parts. Looking at the question, you should understand that. Okay, you can do it easily using that concept. Okay, now let us start. We will do that using it. Okay, yes, so that's it. Shashank, that the problem itself is like that. It is given like that itself. Okay, yes. So yes, you can do that also. It's left to you. If you're doing it, do it carefully. That's it. Okay. Okay, yes, N is, yes, very good. So most of them were able to do it. I'm happy regarding that. Okay, good. So, but I'll be doing it because there are other students who have not finished that problem. So let me do it for them. Okay. So what I will do is, next we'll start with that problem. Okay. So let us start. So the first problem what they had given is, they have given 1 plus 2 plus 3 up to n minus 1 n, and then you have here n minus 1 and so on. Okay, up to here plus 3 2 1, this is equal to 289. So we can use the concept from here to here, or it is like there are many ways to solve this, students. I'm taking one of those ways. Some of them, what they do is, they can reverse, this is one part, right? Again, same thing, if they do this addition with this, then they can take two common and then keep n separate, that and all they'll do. So that's left to you, how do you do the calculation. Or else you can stop this as up to n minus 1th term and then take other as a reverse order. That is also possible. Some of them do it. So now what I'll be doing is, I'll take first n terms as one term and then the other one. I'll be using here, since it is the sum, I'll be using Sn is equal to n by 2, 2a plus n minus 1 into d. So the for the first sequence, okay, remember for the first one, and this is for the second one. For the first one, a is 1 and d will be 2 minus 1 equal to 1. And for the second one, a is n minus 1 into 1 and d will be, please understand, you may not be able to find from here, so you can do it like this. So second see here, this is the following, this one next term, and this is a preceding term, so we can take that as 2 minus 3 is equal to minus 1. This is what we get. So using that concept here for both the this one, I'll get it as, here there are n terms, here there are n minus 1 terms. Okay, this has n minus 1 terms and this has n terms. So using that, you will get this one as n by 2 into 2 into 1. Okay, so plus n minus 1, because it is n is the number of terms, so n minus 1 into d is again 1. Okay, into 1. This is what you get, plus here n minus 1 terms, okay, divided by 2. 2 into, what is the first term? N minus 1. So that will be here, plus please understand there are n minus 1 terms. So it will be, when I substitute here as n minus 1, the other n minus 1 remains here itself. Okay, so please understand this carefully. D is here minus 1. So I'll write that as minus 1 here. Okay, so this is minus 1. This is what you have. So now once this is done, here n by 2 into 2 plus, I'll just multiply, I'll get it like this. Okay, this directly can be written as n into n plus 1 by 2. It's left to you. You can do it if you remember that. I think it was done last year or something. So n minus 1 by 2, here this will become, please understand, 2n minus 2, and this one here will give me n minus, okay, please understand, this will give you n minus 2. So minus 1 into each of this we have to multiply. So then in that case, it will give you here, not plus, it will give you, okay, minus n, minus into minus, that will become plus 2. So this will get cancelled here. And then here it is n by 2 into n plus 1. Okay, please understand, plus n minus 1 into, here 2n minus n will give you n by 2. Now take LCM here. Okay, don't forget RHS is 289. I have not written it here because there was no place. Okay, please don't forget that, 289. So this is what you have. Now take this, it is n square plus n, and here you multiply this n to this, you will get n square minus n. So n minus n plus n gets cancelled. You will get it as 2n square by n, 2. So 2 and 2 gets cancelled, 289. So your answer is n is equal to root of 289, which is 17. I'm not taking the negative value. Please understand, I'm not taking the negative value. The reason is we have to consider that as number of terms. Okay, is it okay? Okay, yes, n is equal to 71, 17. Many are getting. Is it fine now? Now you have understood? Okay, wait. No, we will take only as positive. Okay, yes. So you want me to explain once again? Yes. So I'll do that. Okay, I'll okay, show you where. Okay, let me do that. Okay, yes. So now it is proper. Let me explain. So some of them had a doubt. What I had done is I had taken this into two parts. Like I have divided it into two APs. And since there is an addition sign, it indicates that we have to add this. Then I know that first n terms of an AP is sum of first n terms of AP is given by this. So what I have done is I have split into two parts. In the first part, I have n terms. So that is why first term is A and D is 2 minus 1, 1, and n terms are there. In the second part, first term is n minus 1. And if I want to find the common difference, it is 2 minus 3. Answer is minus 1. So there are n minus 1 terms. How do you understand? Starts with 1, ends with n minus 1. So there are n minus 1 terms. So what I've done here is I've substituted everything, whatever data I have in two cases, in this formula. So then what I have done is I have multiplied this. Okay, here what happens to, after before multiplying, I mean here I have multiplied, not this. Okay, this one I have multiplied, I get n minus 1. Then 2 minus 1 is 1. So n plus 1 remains here. N by 2 is outside as it is. And here what I have done is 2n. So 2n, 2 into 1 is 2. Then here what I have done is this one minus and minus, it will give you minus 2. So minus 1 into n will give you minus n. Minus into minus plus 2 it gives. So 2 and 2 cancels, and then 2n minus n will give you n. And then what you have to do is I have taken LCM as well as I have multiplied. So 2 is a LCM or a common denominator, and n into n gives you n square. N into 1 is n. Again, n into n is n square. N into 1 is minus n. So minus n and plus n cancels. You get n square, 2n square by 2, or n is equal to 17. Is it okay? Okay, yes. So okay, Asha, you can do that. Okay. Yes, you can do it. That is fine. But then you can just check it. Okay, yes, you can do it, because what happens is addition is commutative, right, Nidhi? So you can do it. Okay, yes. So that's what I said. No, I'm taking one of the methods here. Okay, if you want it, you can just do it any way you want. I have told you in the beginning only there are actually three methods. So what I can do is I can just skip this as only up to n minus 1 term, and then take the next one from n to 1. Then that is also possible. Or else some of them, what they do is they take first n minus 1 terms, and the second n minus 1 terms they add them and take 2 common, because that they 2 times 1 will be there, 2 times 2 will be there, up to 2 times n minus 1, and n remains outside as it is. So that's another way of solving it. So whatever is comfortable for you, you can do it. It's okay. Is it okay? Fine. Yes. So this is one of the ways you can do anyways. As I said, see, this can be reversed also, because the addition is commutative, because when you are adding it to this, obviously you have to reverse it. Okay, so that is fine, you can do it. Okay, yes. So that's it. So that's about the this one here. Now is it fine, students? Everybody has understood? Okay, yes. Last step. Okay, I have explained everything. Now I hope it is clear, because some of you had asked me to explain again this, since there was some technical error and all that. So I have done that. Okay, yes. So that's it. So last step, nothing but n square is there. Take a root on the other side. It will become plus or minus root 289, which will give you plus or minus 17. But the number of terms cannot be negative. That is why we have taken only the positive 17. Okay, that's it. Okay. So now let us move on to the next part. Anybody has done using any other method, as I asked you to do it in the beginning, like I had given you, this is other possibility. Okay, anybody has done the same thing, and are you getting different answers or same? Okay, yes, that's nice. So you can do it in any manner. Okay, yes, as I said, see, this you don't have to do it also, substitution, you know that. This one, yes. Okay, that is good, using that n into n minus. Okay, that's nice. Okay, yes, that is also fine, you can do it. Okay. Okay, substitution. Yes, that's good. Okay, try with the different things, students. That will be easier. Okay, yes. So here also, actually, if you observe, this is nothing but the sum of first n minus 1 terms of a natural numbers. Okay, yes. So you have got that correct. Now we'll move on to the next one. Okay, yes. So the next one is, yeah, I have to show you the questions now. So next is this one. I've already given you, so you don't have to bother about it. I have given you the additional one more formula, which is not here, students. That is nothing but n by 2 into a plus an. Okay, or you can even have it as n by 2. It will be a plus L. So this is another formula. So you can use this along with this. Okay, but remember where to use this and where to use this. Okay, that has to be remembered. Okay, next we will move on to the next one. Yes, so they have given you this. It's very simple. Let us move on to the next one. Find the sum of the following: 40 to 22. Okay, then there is one more problem. Find the capacity of the auditorium. Okay, yes, so that's it. So please write down this. Okay, yes, already they have sent me the answer. Very good. Yes. Yes, Ketan. Correct, correct. It is correct. Okay, yes, good. Which one, which formula you have used? Sn is equal to n by 2 a plus a l, is it? Okay, yes, Pratyusha. Correct it is. Okay, yes. So that's it. Now let us move on to this one. Here, first. Okay, first we'll do this and then we will do this. Shall we start? I'll do it in the board. This one, students. I'll take whiteboard and do that. Okay. So the first problem was starting with the 40, then 38, right? It was 40, 30. Is it correct? Okay, I'm sorry, it is not 38, it is 37. Okay, then you have plus 34 plus and so on up to 22. Okay, so there I have not written all the terms, okay, because it is not necessary for me. A is equal to 40 here, D is equal to 37 minus 40. Answer is here, what is it? Answer is 3, right? That is minus 3. Now we'll move on to the last one. A n we know, or we can even take it as last term L. So according to SN formula, it is n by 2. How many terms were there in between? There were, if you count, you can go back to the question, there were 7 terms. Okay, please understand, 7 terms were there. You can count the number of terms. It's very simple. So according to that, this will be A plus L or AN. It's left to you. As I said, 7 by 2, A is minus 3 and L is this one, right? Yes or no? Correct? Is it this one? Sorry, A is not 3, it is 40. I'm sorry. Okay. D is not required at all here. If you want, you can calculate, because if you are using this one, what is that? One more formula, then D is necessary. Otherwise, not necessary. This step is additional. If you are using that other formula, Sn is equal to n by 2 into 2A plus n minus 1 into D, in that case, yes, this is required. For this formula, this is not required. Okay. I'm sorry, here I've written I'd written minus 3, it is not required. A is 40 here. Okay, A is 40 here, so you will get it as 7 by 2, 62 here. So this will give you here 31, right? Yes or no? So you will get it as 217. Okay, so this is your answer. Those who have not finished, please do it. Okay, it is 40 here, first term A, and this is an or the last term according to your wish. Okay, this is about the first problem. Then we have the next problem, which is nothing but the capacity of the auditorium. So we'll go for that. Okay, so according to the given question, please understand. Okay, according to the given question there, determine the seating capacity of an auditorium with 30 rows. So 30 rows, in the sense there will be 30 terms. If there are 20 seats in each, in the first row, 22 seats in the second row, and 24 seats in the third row, and so on. So here first we need to write the AP. Okay, yes, many of them have got the answer. We'll see. Okay, yes. So how we can find out? So now it is very easy. First you need to write this one AP here. So the first row has 20 seat capacity, second row it is 22, third, like that, up to how many terms? Up to 30 terms. Why 30 terms? Because there are 30 rows. Please understand, there are 30 rows. So we don't know what is AN here. We don't know that. We can find, if you want, you can do it. Or else you have a formula directly. Sn is equal to n by 2 into 2A plus n minus 1 into D. So you can use this. So here D is 22 minus 20. Answer is 2. And n is 30, because 30 rows, and then A is 20. You can use this directly. So you will get it as 30 by 2 into 20 plus n is 30 minus 1 here into 2. 30 into this one will give you here 15. Let me directly write that itself again and again. I don't want to write. So 40 here plus 29 into 2. So your answer will be 15 into 40 plus this will give us 58 here. Correct? Yes or no? So what you will get here? Your answer, what it will be? Your answer will be 15 into this one, 98. So whatever your answer is, you'll get it properly there. Are you getting? What is your answer? Now at least. Okay. Okay, now their answers have changed. That time it was something else. Now, okay. Just check, Pratyusha, what is it? Okay. Different answers have come up. Mm. Okay, you want me to show the question? Okay, yes. Okay, just let me show him the question. One person is asking for the question, students. Okay. So this is the question. Okay, so this is a question. I hope you have noted down. Okay, now answer is correct. So most of you have done it. The answer is 1470. Almost everybody has got the answer. I think some of you might have missed somewhere the calculation, student. Just check it. Where we miss mostly is we miss this 2 there. Okay, then in that case, your answer will be 1100 and something, and all that happens. Okay, so see that you complete this. So your answer is nothing but it is, yes, because here, what do you get? 15 8s are 120, right? Then 135 you get. So 12 you need to add. Your answer is this, correct? Yes, we'll move on to the next one then. So that's all I had shown you. Okay, yes. So please see that you complete that problem. Okay, next we'll move on to the next one. So some random examples are given here. Okay, you are given random problems here. So this is the first one in that. In an arithmetic progression of 200 terms, okay, there are 200 terms in that arithmetic progression, and they have given 27th term is 2. Okay, and 17th term is 174th term is 4. Okay, this is there are the two datas given. You have to find the sum of all the terms. Is it okay? Second one is very easy. You just tell this one, you note down all the questions, then we will see. Okay, then the second term is nothing but you have to add the numbers from 100 to 50. Okay, 100 to 50, don't just write 50 terms, 50 is included. Okay, if it is 51 to 100 terms, there will be only 50 terms, but including 50, there will be 51 terms, right? Okay, and this is the another one. Divide 32 into 4 parts such that all of them are in AP, such that the ratio of their extremes. I hope you remember what is extreme and means in the case of proportional and ratios and proportionality. There it comes. I hope you remember that. Done? Have you noted the question, students? Yes. Have you noted the question? Oh no, just do it quickly. Okay, yes. So I hope you have this material, students. I mean that this one I've added in between few problems from different places. So that will be there. I'll be taking different problems from somewhere and all. Other than what is there in the textbook also, I'll be taking different problems. And then we have workbook today. So that's why I want you to finish it fast. Okay. Kindly finish till here at least. Okay. I hope it is done. Shall we move on to the next one? That is solving part. Okay, let us move on to the solving part now. So let us start with that. What was the given problem? They had, there were how many terms? N is equal to 200. There were 200 terms. Okay, I don't want this part of to be visible here. So let me clean that part. Then it will be easy for me to write. Okay, N is equal to 200. And what they had given, what else they gave? They have given 27th term is 2. And 174th term is 4. This is what is given. Those who don't know, once again I'm showing you the question. Please read the question properly. They have given 200 terms are there. 27th term is 2 and 174th term is 4. And we have to find the sum of all the terms. So please understand, 27th and 174th term we know. So how to find the sum? Anyone can tell me how we can find the sum? What we need to find? Okay. Okay, we need to find A and D. Okay, yes, sum is, yes, correct. You need to find, Mithul, just check the answer. Yes, Ketan, I think you're right. Okay, yes. So now first let us find out what is A and D. Shall we do that? Okay, A and D. We have to do that. So first thing is A plus 26D is equal to 2. Because I am doing, what I'm doing, I'm substituting in A plus N minus 1 into D. In that I'm substituting first N is equal to 26 and then I'm substituting N is equal to 174. Then I'll get it as A plus 173D is equal to 2. And you have to subtract here. Okay. Sorry, this is 4 here. Okay, please understand this is 4. So this is what you get. Okay. Please understand here you will get it as minus. Okay, what is the A value? Anybody can tell me? Anyone can tell me what is the value here for A? Sorry, not A, D. What is the value for D? Okay, D is, okay, let us see. Let us wait for some others also. Okay, Navya, can you tell me in terms of fraction? That would be better, I think. Okay, you can do it. Okay, yes. 2 by, yes, correct. Do you get it like that only? Just check, Navya, your answer. Okay, Sumay, just check your answer. Yes, Shashank is correct. Mithul is correct. Yes. Anika, it is correct. So you will get here this side. Okay, 147 into D is equal to minus 2. This gets cancelled. D is equal to 2 by 147. Correct? So this is the answer. I am not going to go for decimals and all that because it becomes really easy when you have fractions rather than decimals. Okay, because there you may lose some of the parts of the decimal and you end up with the answer which is not accurate. Okay, let us go for the next one. Next, if I get D is equal to this one, I can go back to any of the equations here. So any of the equations in the sense I can go for A plus 26D is equal to 2. So now substitute A plus 26 into 2 by 147 is equal to 2. So then here you will get it as A is equal to 2 minus 26 into 2 by 147. So 147 will give you 2 into this will give you that is 194, right? So sorry, 294. Okay, 294 here minus this will give you 52 divided by 147. So this will be, what is A value? Now can anybody tell me A value? Yes, A is okay, 242 by, yes, it is 242 by 147. So you get A and D values here. So next we'll move on to the next part of the calculation. Okay. So the next part of the calculation is Sn is equal to N. N is 200 by 2. Okay. 2 into here. What is A? 242 by 147 plus 200 minus 1 because there are 200 terms. Okay, into what is D? 2 into 147. So do that, you will get the required answer here. 200 here will become 100 after division. So this one will be 242 here, 2 into 242 plus 199 into 2 by 147. So this is what you get. So now you tell me what is that you get answer here. This is what you have to do, simplification. Okay, yes. So yes, Shashank, it is correct. Already this one, Ketan has given the answer. Okay, correct. So now others, are you able to get it? Do the calculation properly. Got it? 106 is it, Mithul? Just check properly. Yes, Mithul, correct it is. Yes, yes. Those who have got now, it is correct. Okay, yes. Sumedh, you can simplify that. Okay. Yes. So your answer will be, as many of you have finished with your calculation, it is 6. Anvita, don't forget, outside there is 100. Multiply that. Your answer is only inside what is there for the bracket, that one. Okay. Multiply that 100 which is outside. You will get the proper answer. Okay. Yes, correct. Now this. So your answer is nothing but it is 600 students. Okay. 147 will completely divide the whatever term remains inside the bracket there, and you that will be 6, and then 6 into 100 whatever is there outside. Your final answer is nothing but it is sum is 600. Is it fine? So this is your answer. Now we'll move on to the next one. Okay. Shall we move on to the next one then? Okay, next one. I think what you can do is, next one, I think you can do it as a homework, students. Is it fine? Can you do this? Because we had done this kind of similar kind of problem just that time. You remember? Yes. So I think you can do this, but please understand here A is 100. Okay. I'll just give you an explanation. D is 99 minus 100, which will be minus 1. Okay. So that is what you get. And there will be how many terms? From 51 to 150 terms, and then plus 1, which is the 50. So like that you can do it. Now shall I do this problem here? Divide 32 into so many parts, that is 4 parts, such that they all are in AP. Correct? Yes. Okay, so let us go to that part. This will be your homework. You tell me what answer you get. Okay, what is your answer here? This is your homework for today. So divide 32 into 4 parts such that all of them are in AP, such that the ratio of their product of their extremes is to the product of their mean is 7:15. Now I want one answer from all of you. When we have 4 terms in AP, how do we take them? This I had told you in the previous, previous sessions, that is in the polynomial case. I had told you how do you take the four terms in AP. Now I want everyone to recall that. How do you take? Okay, yes, most of them have reached already the answer. Okay. Mithul, is that so? Okay, yes. It is nothing but A minus 3D, A minus D, A plus D, A plus 3D. Yes, that is how you take it, right? So this is actually they are in AP. You can check, Nidhi, if you want. Their common difference remains the same. So that is why these are in AP and they are consecutive terms. Just check it out. You'll be able to do it. Just to do that. Okay, our main aim is, why do we take is, see, whenever they give you that sum, right, they have given you there the sum. That will be there are no 4 numbers whose sum is 32. In that case, what is our main aim is to cancel that D term and get A. So that is the this one. Okay, so this one question is, what is that we had, students? Please recall once again. It is divide 32 into 4 parts. So when you add all the 4 parts, you should end up with the 32. And the product of their extremes and the mean, that is ratio between the extremes and the product of their means, is nothing but 7:15. Okay, please remember that. Is it okay? Shall we start? So how many terms are there in AP? There are 4 terms. So it is taken as A minus 3, A minus D here, A plus D, and then A plus 3D. Is it correct? Okay, are they consecutive terms? You can just check it, difference between them. A minus D minus of A minus 3D. Minus becomes plus here, correct? So then you will get A and A cancels. This is 2D. You can check the other terms also. A plus D minus A minus D. So that will give you A and A cancels 2D again. So again, you can go for the third one. If you see A plus 3D minus A minus D, so that also will give you 2D. Is that clear? So this is in AP. Okay, don't get confused and think that these are not consecutive terms or something. Their common difference remains the same. So they form an AP. Is it okay? So now let us take this. Now here, what are the extremes? These two are the extremes. Okay, means are like this. We will go for that. Okay, now here, because I have not written that other way of ratios and all that, so you can just do that. Okay, so now let us continue with the problem first. Then what we have is A minus 3D, A minus D here, plus A plus D, plus A plus 3D. This is all together equal to 32. That is what they have given. There is a number 32. You need to divide it into 4 parts. All of them should be in AP. So this gets cancelled. So you get 4A is equal to 32, or A is equal to 32 by 4. Answer is A. Now what to do? Now according to the given data, the product of extremes is this, to the ratio is to the this one. What is that? Product of means. Then it will be like this, that is equal to 7:15. Is it correct equation? Are you getting it? Now what you do? You can go for a square and 3d the whole square divided by a square minus d square is equal to 7 by 15. So now this will give you here, okay, that will give you, once again I'll just scroll it up a little bit, okay. So that will give you here a minus 9d square. A square I can just take it as 8 square if you want. Okay, a square minus d square is equal to 7 is to 15. Now what you can do is you can go for further cross multiplication. Is it okay? So then you will get it as here a square minus 9d square is equal to 7 into a square minus d square. So what you can do is you can multiply 15a square minus 15 into 9, that is 135 d square is equal to 7 into a square minus 7d square. Okay, put all the d square terms on one side, all the a square on one side, and tell me what you get for d. Okay, yes. So that is your work to find out, calculate. Okay, yes. So what is d? Okay. 1 minute. Yes. So some of them have a doubt, so I was just noting down. Okay. So yes, you can substitute a. Okay. There. Don't forget. Okay. Yes. Nidhi's doubt I had missed. What is? Why don't we take? Okay. Yes. A minus 2d and a minus d. Okay. So what do you get d value? Anyone? Yes. Please substitute. Okay, let us see all the messages. Okay, yes, 2. Is it only 2? Are you getting just 2? I don't think so, because there is d square. Yes, plus or minus 2. There are 2 APs. Please understand, in AP it should be plus or minus 2. Okay, yes. So now here, your answer here, d will be equal to plus or minus 2. Correct? If when, then you will have 2 APs here. That is, there are 2 possibilities. What is that is, when d is equal to 2 and when d is equal to minus 2. If you are starting with d is equal to 2, then the first term will be 8, and then second term will be 10, then next term will be 12, and then the last one must be 14. If you are starting with this, is it correct? I'm sorry, 1 minute, students. No, it is not like this. Okay, I'm sorry. Yes. Okay, yes. So I have taken different way, right? So you have to use that only. Okay, so first term is a minus 3d, and the second term is a minus d. You have to take like this. I'm sorry. Yes, a plus d and then a plus 3d. Okay, you have to take it like this. So according to that, 8 minus 3 into 2. So that will be 8 minus 3 into 2 it will be. So that is what you will get is here is 2. Okay, next here 8 minus 2, your answer will be 6, and then here 8 plus 2, which is 10. Okay, 8 plus 2, and then 8 plus 3 into 2, that is, you will get it as 16, right? Is it correct? How many of you are getting this? Okay, yes, D is this one. Okay, correct. Okay, getting it properly. Okay, what will be the other one? Suppose d is minus 2, then what happens? This will become, see, when it is minus, the first term will become 16. Why? Because 8 minus into minus becomes plus, correct? So this will become 16, and the next term will become 10, and then 6 and 2. It reverses. You can check whether when you add this, will you get the same thing? Will you get same thing? Yes, 8 minus this one, correct? 8 minus 6, here it is. 8 plus 2. Okay, then here Same answer are you getting? Okay. I'm sorry, where did I make mistake? Ah, yes, here it is 14. Yes, yes, calculation mistake. It is, yes, it is 8 plus 6. I'm sorry, it is 14. Okay, yes. Thank you for correction. Okay, yes. Okay, yes, good. How, okay, you want me to show how did I get 2, is it? It is just simple. See, if A minus 3D, right? A is here 8 because you have got this previously here, right? And then minus 3 into D is 2, right? Because positive 2 it is. So I've taken 2 here. So what you will get? 8 minus 6. Answer is 2. Is it okay now? Fine. That is how I have got 2. And other calculations you want? Yes, D is 2. Then next case I have changed. Next case is here. See, here is the next case. Next case is here. This is when D is equal to minus 2. D is equal to plus 2 is here. Is it okay? Fine. Both the cases I have taken. Okay, yes. So is it fine now? Okay, last term is 14. Yes, Medansh, I have corrected it. Okay. Yes. Fifteen square I have not used. I just asked you to calculate here. Okay, I don't know what methods you might have used. You might have come across some multiple of 15. Okay, yes. Okay, you simplify this. Shashank, you need to simplify this expression here. Can you see this? This expression you have to simplify this. You need to simplify this. Okay, so you will get it if you simplify that. Okay. You will not get d is equal to 2 directly. You will get d is equal to 4. D square is equal to 4. Okay. You will get d square is equal to 4 and then take a root on both the sides. It will give you d is equal to plus or minus 4. Okay. Fine. Okay. Yes. So that's it. So now we'll move on to the next question. Okay. Next question. Yeah, applications now. Okay, so now most of you had a question, where do you get all these applications of the AP? Actually there are different applications. See here, what is this? It's a very famous comet, isn't it? Yes or no? So that appears only once in, actually, see here what we have done is we have taken it precisely 76 years. But the this one, the orbital period of that comet is not 76. It is between 75 and 76. But when it is taken as 76, it will give us approximate year in which year it will appear again. Okay, it had appeared on 1986. Okay, now again it will appear near the earth. Okay, we can just see with the bare eyes, just like that, naked eyes, we can just see that a comet. It will come once in a 76 years. So we have to calculate the next 3 years when the comet will appear. That is what is a question. So first application is that we can use these kind of that is a arithmetic progression in these kind of applications. Okay, we can find out in which year what will happen, something like that, if you know a certain pattern. So then we know this, there is a one more. See here, the earth has a circumference of about 40,000 kilometer and every day what happens is earth rotates and it completes one rotation. Suppose you stay at one point, okay, one point on the surface of the earth, because we are on the surface, we are not near the core or something like that. Okay, and you have not done anything. Okay, if you are standing at that point still, then along with the this one earth, you will complete one lap, or what we can say, complete one rotation. So it means you are also traveling along with the earth, right? So you will be completing that 40,000 kilometer lap around the center of the earth, because you know, right, that earth rotates around itself. That is that there is an axis of rotation. According to that, it just rotates. And not only that, it rotates around the sun also. That is also there. So according to that, here we have taken the rotation of about its axis. So in 1 week, okay, how much distance you cover? So that is also can be calculated. Or there are other this one problems, like, where you want to give scholarship to one, like, 7 students or something like that. You have certain amount, maybe you have 4,000 amount, and you want to give it to some students as a scholarship. How do you do that division? You may have in mind that I want to give, suppose first person is getting some 1,000 or something like that. I want next person to get 100 or 200 rupees less than that person. Obviously there will be a difference, right? Those who is the top, like those who are toppers, they get more money, and after that second topper and all that, the money amount goes reduce, it just, it becomes less and less, right? They keep at least 2,000, 3,000 difference. That is where the AP comes into picture in one more cases. And there is one more small application, that is where we will be using the volume concept. Okay, suppose if you see, that is the small terrace has to be built in a football ground. Okay, they want to find out what is the total amount of concrete. They have the, the steps, they know what is the height of the steps, what is the length of the step, and what is the, this one, that is length, height, and the width of the step. Okay, using that concept, okay, they can find out what is the amount of concrete required for each step, and then totally they can estimate that they may need so much of concrete. Like this kind of problems are there. There are many others. Maybe if you consider your savings. Okay, suppose you save to this month 100, and next month you want to save it, make it that savings as 110 rupees, and next month you want to make it as 120. Like that, every month you go on increasing the amount by 10 rupees or something like that, and you want to know at the year end how much will be your amount. That can be easily calculated using all these kind of APs. Is that okay? So these are the few questions we have, and here is one different question which I have given you. So that's it. Okay, these are the different applications we have from the this one. So the first one, anybody has solved, students? Okay, anybody has solved? Okay, yes, Amit, it is correct. Yes. Again, this comet will appear only on 2062, and after that, okay, after that, yes, okay, yes. So many of them are, yes. After that, it appears only after our death. Okay, most of them, most of us may not be there, because it appears only in 2100 one yeah 2138. Yes, correct. Yes, yes, nice. Maybe we will get to watch that comet only on Halley's comet on 2062. That's the only chance we have. After that, it appears only on 2138. By that time, we will be almost, I don't think many of you will be, many of us will be alive that time. Okay, if we are there, it will be nice. Okay, yes. Yeah, it depends again, Pratyusha. The reason is, yes, and one more thing is, this one what we have here is, there is one more, there are other factors also. There is a possibility that that comet may crash into something else, maybe, then it may not reach at all. Okay, yes. Okay, yes, so now let us continue. Okay, yes. Yeah, yeah, that's sure. Okay, if we survive this corona effects and all, then we may be alive by that time. Okay, yes. So now shall we continue? We'll continue tomorrow. Okay, that's it. So we will solve all this tomorrow in tomorrow's class. I don't know how many of you have noted down. If you are able to do it, it is well and good. Okay, I know it's your break time. So I'll just stop here. Okay, yes. So that's it. So we'll do these problems tomorrow. Okay, thank you, students. Okay, those who have noted down, please solve at least these two problems. Okay, yes, first some of them have already solved it. Okay, thank you, students. We'll meet, maybe I'm not sure, tomorrow, or I think it's on next week, or maybe Friday. I'm not sure. Let us see. Okay, yes, thank you, students.
We'll get started. Guys, you'll have to switch on your microphones, okay? Sorry, not just microphones, the video cams, okay? We've been told to turn on, so please do. I think I'll be transferring you guys to your... Yeah, on your PC itself. That's exactly what I'm talking about. Whoever has this thing, whoever has webcam, whoever icons we can see as webcams here. Or it is a confirmation that an icon exists, webcam exists. I know that Ashay has a problem with that, and okay. Is that turning on? Okay. I think who's left then is Amit is left. I think Amita has gone somewhere to have breakfast. Vivek is probably not there. Shashank, even he is gone. Others are fine, yeah. I think, oh, suggestions, okay, Namakarana suggestion. Yeah, dual monitors, there are dual monitors. I'm trying to basically take the most advantage of it. And plus you've been told to turn on this thing. So for the Lion King, why is it that the top suggestion? Darth Vader, no, not going with that. Peppa Pig, what's that? Okay, not seen that. There's Grim Reaper. If I know the situation, is Phoebe, okay. Doctor Who, okay. Oh, there was a lot of suggestion for this and I didn't do this, so I'm going to do it this one. I'm going to go with this one. This was been a suggestion for a long time, but that never happened, so we'll go with this. Oh, this is weird. This is super weird. I don't know how to type that into the box, so that's not going to happen. I got student. I'll go with it's not possible, so I'll go with the most nearest possibility of this thing. I know it's not that, but we'll go with it. Okay, this was the top suggestion that came in, so we'll go with that. Okay, for the day, done. Going ahead, some teachers now. Okay. That's Elon Musk's baby's name, by the way. Anyways, going ahead, I think we'll start with the class. So a few things. Towards the end, how many of you can? Okay. Now, whoever needs a recap of angular magnification or a discussion about it, I'll be doing that at 6:45 and beyond. It will go up till, it can go up till 7:15 if you want, depending on your questions. Is that fine? Yes, Keaton, question number 16 is the derivation of time dilation. That's not a very hard one. Is that fine? Okay, we'll bring the recap then. Is that fine? Okay. Now going ahead, there'll be a detour on angular magnification and other things. I'll be discussing those. Sir, I have to put this. Guys, Pratisha has broken her finger since she has to go to the hospital at 6. Okay. So in the DPP, isn't the second question supposed to be mirror formula? No, it's not mirror formula. It is the normal, your mirror formula and lens formula both look the same. Okay, there's no difference. Actually, last year's mirror formula is same as this year's lens formula. It's just that the conventions are different. That's the textbook convention. That's what we did, right, last time? Yeah. So what the last questions can we ask the end? Yeah, sure. Do you, no, later, everything later. Okay, lens, done. Now going ahead, we'll get started. I was discussing something that is this. I told you there's a difference between few things, right? One is there is something called difference between a voltage at and voltage, something has a voltage of. So when I'm talking about here, I'm talking about potential, and here I'm talking about potential difference. Do not forget that. Okay, these two are different things completely. Yeah, I told you about voltage drop and voltage gain. Do you remember that? You drop the voltage as you go from one point to the next, and then you can have a gain in voltage, gain in potential. Do you remember that? Voltage drop means usually potential difference. There's a difference. Can I get a yes on that? Do you guys get it? Okay. If you know this difference, I don't have to struggle a lot. Then I can go ahead. Okay. Gain means potential gain means you across a battery, when you go from if you have a battery like this, or negative plate and positive plate, if you are, this is negative charge, right? This is positive charge, positively charged, maybe probably it's at a higher potential. So if you go from, let's say if this is a 18-volt battery, you will go from 0 volts to 18 volts at the top. The potential is 18 volts at the top. Is this part fine? Did you guys get this? Others, whoever asked that question? Okay, I'll go ahead now. So I think I did the simulation. This was done. Do I have to explain anything here? Does anybody have doubts with this? I told you, right? At the end of the day, if you have two charges, you have a circuit, kind of. Okay. Yeah. If you get kicked out, there's a waiting room. So be careful. Okay, I've enabled the waiting room. How can a charge have a voltage? The charge doesn't have a voltage. The charge creates a potential which leads to voltage across 2 points in the space. The charge creates a potential around it, potential energy, potential, which leads to potential difference around it. Is that fine? So if you go from one, potential will vary depending on distance. Let's like Earth's gravitational potential, it varies from distance from the Earth, right? Similar from the charge, there'll be a potential changing as you go further and further away. Is that part fine? Oh, you guys have a confusion messaging. I think I've clearly been very clear of my name there. Says XV1, whatever. Do not send too many S's, you'll be kicked out. I promise you won't be able to come back today. Okay. Yeah, the X, this thing, whatever you see. Okay. How is it pronounced? I have no idea. They say it's pronounced Kyle, but I don't know. Okay. Yeah, this is me, Muralidhar. Yes. Okay. I'll just explain for one last time this thing. This is important, that's why. Remember this? To add a positive charge. I told you it creates a potential around it. So if you look at the potential and different regions, look at the value. It's 12 volts. It reduces, becomes increases. Sorry, as you go closer and closer, it increases. Think of this like a hill. I've told you yesterday, right? Think of this as if you're climbing a hill. You're going to the top of the hill. It becomes higher and higher. Can you explain magnitude thing tomorrow? I didn't think. Okay. No, I didn't get that. Okay. Anyways, now as you go further and further away, it becomes a well. Like at infinity, it goes to 0. Okay, at infinity, it will go to 0. Is that part fine? Can I get a yes or no on this? So if I have a negative charge, this acts like a valley. Send me one yes. If you say more than that, I'll kick you out right now. Okay, for me, it's a click away. That's right. Can you explain the flow of electrons in blue tank? Oh, basically what I was talking about, not tank, in a pipe. So electrons, I treated them like water molecules, and they're flowing through some sort of pipe, a wire. So in some regions they have to go slowly, in some regions they have to go faster. Okay, that's what I was getting at. I think some of you submitted. 1 second. Yeah, don't send hail firma. Okay, do not send hail firma. Okay, I'm gonna kick Pratisha out just to show you that it's possible. 1 second. Just, oh, she's saying no. Okay, fine. She begged. So anyways, going ahead. That's how you beg. Now, anyways, going ahead. So you know that you can see here as you go closer and closer, the potential. This is a valley. This is basically like a valley. You're going to the below sea level. You can say below sea level. So you know what happens if you climb from the below sea level region to the top of the hill, right? Will you spend energy or gain and lose energy? By the time you reach the top, yeah, you know that you would have gained a lot of energy. So basically what I'm trying to say is there are drops here, potential drops, okay, potential gains. So across these 2 points, if you see from this point, if I draw part 10 volts, this is at 4 volts. So can you tell me what's the potential difference between them? What's the potential difference? This is at 10, this is at 4. So roughly how much? 6 volts. So agree that if I place a battery there, if I place a resistor there, how much current will flow through it? If I were to place it in thin air, let's say, somehow, what will happen? How much current will flow through that resistor? If you climb a hill, you will lose energy. That's what I said. If you're going to lose energy as you go higher. Do you guys get that? Now I don't know whether you realize this. If I just keep a wire, let's say I have a positive charge and negative charge, and if I keep a wire, Muralidhar, 1 yes, yeah. If I keep a wire somewhere hovering there, a resistor, you will have current flowing through it, just up in the air, right there in that location, in those two locations, across it. Did you guys get that? Send me 1 yes, I'll kick you guys out. Okay. Okay, nice, cool. But the source should be powerful enough. Yeah, source should be powerful enough. Yeah. Okay. Anyways, going ahead, I think we'll go to the presentation back. Okay. Whoever sent that, yes. Anish will be sent out for 5 minutes. Come back later. Bye-bye. Just to show that it works. Okay. Where is it? Where is the feature to do that? You'll be sent out. One second. It's easy, not that hard. Where is Anish? Yeah, here we go. Done. Bye-bye. He's gone. So he'll come back in 2 minutes. Okay. So just showing that it's possible. Okay. I'll bring him in 2 minutes back. He's gone. Bye-bye. Yeah. He'll come in back in 2 minutes. He's going to miss some demo. He's asking me to join the class. I'm not going to let him in. Done. Okay. So you want to see him begging? It's here, right here. Okay. Anyways, see waiting room. I'll message him. Wait. I'm messaging him in the waiting room. Wait for 2 minutes. Yeah, done. Anyways, going ahead. So he's in the waiting room. Okay. Now, going ahead, this is fun for me. Okay. Now, there is a good video if you're interested in. This is by Eugene Kuturyansky. Thankfully, a student 2 years ago taught me how to pronounce this. It's called Eugene Kuturyansky, by the name of Eugene Kuturyansky. Okay. Papa will get him back. Just adding him back now. Okay. Yeah, how was the experience, Anish? Being the outstanding student for some time. Okay. Is it there? Okay, fine. I don't see any messages from him. I can even disable his chat feature, I guess. I think it's possible, but later. Okay, fine. Anyways, going ahead. Yeah. Now going ahead, I guess he left. No, that's not possible. He's in the chat. I can see him. Okay. He's in this thing. And where is this microphone? Yeah, he's there. He's there. You can see him in the video. That's him there. See, you guys see him? Yep, there you go. Bye. Anyways, cancel the spotlight video. Done. Okay. Now going ahead, this is an amazing video on by Eugene Kuturyansky. He's very famous on YouTube. This speaks about something called gradients and partial derivatives. You know there's calculus, right? It's complicated. Calculus can always be complicated. So, this is kind of going to give an intuition about what derivatives and partial derivatives are, because you need those ideas. Otherwise, it doesn't make sense to speak about valleys and hills and stuff like that. You can basically say wherever there's a hill, you can say there's a positive charge, and wherever there's a low, there is some sort of negative charge or something like that. It explains a lot of ideas, but I think you can check it out on your own. Yeah, I think it discusses a lot of ideas. It will also discuss why I was calling it, what you say, a hill and a valley. Yeah, Anish, if you send one more message like that, you'll be out permanently. Okay. Anyways, going ahead. Where are we at? Yes. Okay. So, yeah, later. Where is it? So check this video on your own, your choice. Now there is something fun for you guys. You might love this. I promised you something, right? I promised you something. Every class, you will have one of this. Muralidhar, one message.
Hi, my quest to find a greater power, I came across.
Okay, so this is fun. This is fun to try. Here's a Tesla coil. Now, for those of you who don't know what a Tesla coil is, Tesla coil produces an strong electric field around it, or it creates a strong electric field, as if it's a point charge. It acts as if there's some sort of charge and there's electric field created around it. Okay, so starting with the video, I'll just share the sound. I'll share the optimize for clip. Get ready. It's going to be loud. It does it. It just does it. Take my word for it, does it. Now observe this, okay?
Hi, on my quest to find a greater power, I came across things at lower power, which were rather beautiful. I mean, look at these arcs created by my circuit. They are in order of 100,000 volts, and yet the only sound you hear from them is the sound of stupidity. I'll show you a few things which you can find details about in my website. Again, these are big arcs coming out of the coil with very little noise, unlike some other coils.
Okay, can anyone tell me why are those sparks coming off? Sparks indicate that there are electrons flying off. Agree with that? I told you, wherever there's sharp end electrons here, pointy tip, it's a pointy tip. Now, why are the electrons coming off? Tell me. Why do the electrons came out of his finger last time? Tell me. Why did they come out of his finger? Earlier. Remember that guy who was doing that experiment where he was pointing the finger? Not just a sharp end, not just a sharp end. He was pointing it towards what? He was pointing it towards something that was of lower potential, the ground. Agree with that? Remember that? He was pointing it at something that was at 0 volts or grounding dome. Yeah. So exactly what's happening is the Tesla coil generates very high voltages around it, volts potential around it. These electrons are flying off away to go to those locations. Is that part fine? They're going towards the lower potential. They're flying off as much as possible. Okay, if that clears that part off, you must understand. Yeah, they need to. The idea is the potential. Can you see my cursor? Can you guys see my cursor? Yeah, the potential at the tip of the wire and the potential far away will be different. Agree with that? Do you agree that the potential very next to it will be different? There's a strong electric field. Otherwise, the electron wouldn't be pushed out of the wire unless there's a strong electric field. Okay. So there's an electric field, there's a potential difference, there's a difference in the voltage, amount of voltage. Okay, now observe what he's going to do next. This is fun.
Because they are running at very high frequencies and are not modulated with low audible frequencies. Like I showed before, if I bring a fluorescent light close.
Yeah. Have you seen this? You can glow a bulb or a fluorescent, anything, fluorescent tube or something, just by getting it closer to a Tesla coil, just like that. You don't require wires or anything. Can anyone tell you why that happens? Yeah, there is a potential difference, right? At every point in space, do you agree there's a potential difference? Front of this rod, and if you go away, there's a potential difference. Agree with that? Potentials are different at different points in space. So there's a potential difference across the light bulb's ends. Agree with that? Okay, so that's the reason. So you can try this at home. If you can build a Tesla coil someday, it's the coolest thing to build. You can have this. Did somebody say anything? Most of you are saying PD is present. Yeah, potential difference is present. Nice. Okay.
It turns on with power wirelessly transferred to it. Now look at this regular incandescent light. You can see the flow of electrons in it. But
basically what's happening is the electrons are flowing outward and inward just to go into those, filaments there. You can build it. There are some videos online, but it's risky. It's not simple also. Yeah.
Where are they going? Isn't the glass non-conductive? Whoops, it melted and broke the glass. Here's the driving circuit, which is basically...
This is how complicated the diagram looks, circuit diagram looks for this setup, okay, what he has done. You can build it, you get the components, but it's not simple. It's not that simple to build these things. It takes years and years of time before you're ready to build some complicated circuits like this. I think it melts.
An oscillator making a pulse width modulated waveform. What? Why doesn't it hurt? What kind of sorcery is this? Did it decide not to hurt? Ow! Nope. It doesn't give me a shock when I do it with a piece of metal. It doesn't give me an electrical shock.
You guys can't hear? Can you guys hear? I've shared the audio. Okay.
When I do it with my finger. Ow! Ow! but it burns my skin into a charcoal. Anyways, if I put this piece of metal on top of the coil, it starts spinning. There is a jet of electrons shooting from the ends, forcing it to spin. Now this metal screwdriver is held by strings. And although it's not connected anywhere, the arcs still jump to it. The hell? Ouch! Although the arcs are, ouch! Ouch! The arcs are not jumping to the screwdriver, but it burns my hand. Now I like to change my...
Okay, you can check this video on your own. There's a lot of complicated things that are going on. I can't explain this. This setup is much more complicated, but it understand that it creates enough sufficiently high potential. So if you see, it's trying to increase the amount of potential using a bunch of capacitors. Oh, these are not capacitors. These are MOSFETs, if I'm not wrong. Yeah, this is a MOSFET, I guess. Looks like a MOSFET. There's a device called MOSFET. You can simulate these circuits in every circuit. I've taught you every circuits, right? Remember that every circuit app? You can build these circuits of your choice. By the way, how many of you downloaded Circuit Jam? Circuit Jam? I shared with you something called Circuit Jam, right? An app called Circuit Jam. Why is the color purple? That depends on the gases present. If the gases are of a different thing, the ionization, the color of this thing depends on the gas present. Not yet? Okay. Please download Circuit Jam. Only play one level, not all the other levels. Okay, just the first level. The other one you'll have to pay simply. Don't do that. The first level, just finish it off. Some of you did it, yeah. Yeah, you can make it color or black or colorless.
Check it a little bit.
Okay, you can, depending on the gas. If there's no gas inside, it will not glow it. Okay, so I'll close this anyways. Now going back to the whole thing, where are we at? Share. Okay, there's a question, 1 second. Why can only gases be ionized? Can liquids and this thing be ionized? I don't know. I don't know. I don't know. I have no idea. Can gases, solids and liquids be ionized? Gases, as far as I understand about gases, what I studied is they have, I think, some sort of, but okay, that doesn't explain. Something to do with electronegativity. Have you studied electronegativity? This is chemistry stuff. Ionization has got to do with chemistry. There's a concept called electronegativity, and they have some sort of, I think, low electronegativity, which causes, it's easy to knock off electrons, I think. In case of gases, I think it's easy to knock off electrons when compared to liquids and other things. That might be the reason, I don't know. Amit is saying he can't hear anything. Amit? Yeah, you can't hear anything, so. Okay, fine. Can you hear something? Yeah, I know you can hear, I know. Okay, Pratyusha, enough of yeses. Okay, next is you going out. Okay. Anish also can't hear me. That's a prank, I'm pretty sure. Anyways, there's this movie. Have you guys watched this movie, Sorcerer's Apprentice? Anybody? There's a scene, right, where he makes music with Tesla coils. Do you remember that? He makes music with Tesla coils. Whoever has watched it. Amit, yes. 1 second. 1 second. I think I have to hold the board Amit in front like this to tell him that stop texting. 1 second. Okay, listen to this. 1 second. One second. Connect somehow. I don't know. I'll make it public for him right now. Share your problems with everybody. Okay. Yeah. Anyways, going ahead. So, Sorcerer Apprentice, the movie has been taken out. Okay. And yeah. So I can't find the link on YouTube again. But then there's a scene where they produce music. I know of a band, in fact, which produces music using Tesla coils. So I don't know whether you've been there in Dubai. I heard somebody told me that there's a show where musicians have Tesla coils behind them and the sparks jump off and they produce the sounds of the instruments. I don't know how many of you watch those shows. There are. They just play with Tesla coils, music with Tesla coils. It is known that Tesla coils, you remember that spark which was coming off of electro booms, this thing, and the spark was creating the sound? Yeah, those sounds can be of different frequencies depending on the voltage and many other things. Yeah, Muralidhar, calm down. If you flip out again, right? Yeah. Okay. Now I want to show you something else. Now Eugene Kutyriansky has one more good video. This one is really great. Okay. This is probably the one that kind of will explain you potentials in a better sense. Okay. So listen to this one carefully. Okay. Do not mess this one up. This one is very good. Actually, I gave it as a homework in the other batch, but you guys watch. The music is great. I'm not going to try not to share the music, but anyways, let's see. Okay, listen to this.
The simplest electric circuit is a light bulb and a battery.
Okay, tell me, before we connect things, what happens when the battery is not connected to the circuit? What about the potentials? Is there any potential difference? Is there any potential difference when the battery is not connected to the circuit? Okay, is this clear? Oh, you guys can see the boxes. I'm sorry. Now the box should be away. Is that part fine? Can you see it now? Very clearly, at least. Okay. So when you're not connected, the idea is what they've done is they're representing circuits with the potential differences as heights in the heights here. If there's a large potential difference, there'll be a larger height. Okay. So observe this.
The battery creates a force pushing the charged particles in the wire, causing them to flow in a...
So I don't know whether you got it. Here, you're at lower potential on the negative side of the battery. At the other side, you're at the positive potential, higher potential. Is that part fine? Can I go ahead? Can I play the video? Yeah.
loop around the circuit.
Remember that case where Baldi took some, what's that, ragi mudde from the bottom of the thing to the top? Yeah, that's what the battery is doing here. Why low is the negative side? We just say remember the valley I told you? Valley is the negative charge. We treat valley like the negative charge, Yeah, that's how it goes. Yeah.
The number of charged particles that pass by each second is what we refer to as the current. The charged particles flow through the light bulb because the battery causes them to have a higher potential energy on one side of the light bulb than the other.
Okay, this one is important. Now, this one is very important. This part is very, very important. Listen to this. They didn't show the energy earlier. Now they're going to show the energies. Remember how many joules per coulomb? Remember that? What is joules per coulomb? Voltage, right? How many joules per coulomb is voltage? Yeah. Now observe this.
If we visualize the potential energy as boxes that are attached to the charged particles, then we will see that...
Now does it make sense? Joules per coulomb. Every charge is carrying some energy. Yeah, that should make sense here in this visualization. So the battery is giving it energy basically, and that gets spent in the bulb. They lose it there. They have to spend some energy to, they get spent in the bulb basically. Okay.
This energy is converted into light as the particles pass through the bulb. The charged particles regain their potential energy as they move through the battery, which pushes the charged particles to the higher potential.
Okay, 1 second. I think I can go ahead. So this part is clear.
A battery that has not yet been depleted ensures that the voltage between its two terminals is always at a specific value.
Yeah, I'll come to what if there are more bulbs. Amit, do not send commas. I'll put you out of the class. Okay. Okay, now this part is important. The amount of work for the 5-minute video. Yeah, I know. when will be problems? Yeah, one second. The problems are yet to come. Yeah, I know. Now the simulations are very good. You guys, if you want to understand advanced electronics also, please refer to these simulations. Okay, they're very good for many other physics topics. Eugene Kutiryansky is very good. Okay, his site is very the YouTube channel is really good. Okay, now understand this. This is very important now. We have, if you look at it here, remember parallel and series circuits? Do you guys remember parallel and series? Did I teach you parallel and series? Let's speak about parallel circuits and series circuit. Background music, we'll think about that later. Yeah. Now, some of you said no, some of you said yes. Now, if you look at it, EMFs here, remember in EMFs, I told you series and parallel. If you look at it now, this is connected parallel or series, the batteries, tell me. 3 batteries, are they connected parallel or series or in series? 3 batteries, parallel or series, which one is it? Okay, observe what happens when they're connected in parallel. Listen to this carefully. They're connected parallel, observe this. Remember last time some of you asked a question, what's the use of parallel connection? And here's your answer, okay?
If we place several batteries with the same voltage together in parallel, then this will result in more energy that is stored, and this will give us more time before the battery is depleted.
Did you guys get that? If you had a single loop, you would have ended up spending, the battery would have gotten empty quickly. I've cleared the screen. Are there many boxes? There's only one box, I believe. Okay, playing it again.
More energy that is stored, and this will give us more time before the battery is depleted.
Yeah, I'll come to the series part in some time. One second. They'll do it in series part. Now for this one, yeah, which means the battery life extends. Now, do you see one more thing? Is the potential across the battery increased or decreased? Is it the same? The potential is the same, right? Still, it has not changed. The battery, all of them raise it to the same level. Do you see that? Yeah, all of the batteries do not increase the potential. They maintain the same. So if you're trying to create, let's say you want them to last, parallel connection sounds like a better option if you want the battery to last. But if you connect them in series, what will happen? Can you tell me? Yeah, here we're taking over voltage as being the same. I'll come to that. How do the electrons get divided if the batteries are of different potentials? Yeah, there's a connection. We'll come to that later. For now, I would just want to stick to this. Yeah, that gets a little complicated because one acts like a driving battery, other one acts like something like that. Okay, observe this. Okay, one second. Yeah.
If we instead place these batteries in series, this will cause their voltages to add, resulting in a much higher potential energy for each charged particle.
Okay, do you see something interesting? Here it is 1 joule per coulomb. Now it is 2 joules per coulomb. Can you see that? There are 2 energy packets per coulomb now. Do you get the connections now? The voltage has increased much more. Okay, I'll play it further now. Voltage is high. So if it is parallel, the bulb will glow.
A higher
It'll glow brighter. What this?
voltage across the light bulb means that a higher current will pass through it.
Yeah, did you get that? If the voltage difference is large, more current will flow through it. So that leads to a brighter bulb. Is that part fine? Because the charges coming in will spend the energy in the bulb quickly, all of them, give all of it quickly if the current is more. Okay. Yeah, you see it spends it quickly. Can you see that? The 3 joules of energy also. I know there's a single box. There's only a single box. Yeah. What about LEDs? They work the same way. There's no much difference here. Okay.
This will cause far more light to be emitted by the light bulb, but it will also mean that the energy in the batteries will be depleted much faster. Much more detailed information about
I
voltage.
kept it for the music because I was enjoying the music. Anyways, now going ahead, hope you saw that part. Okay. Can you help me build a Tesla file? I don't know. But before that, why are they falling lower and lower? They're not falling lower and lower. They're just falling quickly. That's all. The current has increased. I know the box, there was a single box, guys, covering a small section. I don't think it was too much. Yeah. I have no idea. It should be Tom and Jerry music, I guess, somewhere. You'll find it in Tom and Jerry. It's some sort of popular music. Yeah. Now, anyways, going back to the presentation, 1 second. Where are we? Where are we at? Yeah, that's one. 1 second. I have to stop sharing the sound. Done. Okay. Yeah, if you keep it in parallel circuits, the bulb will be slightly dimmer, okay, because it won't be too much voltage across it. The voltage will be lesser. Now, do you remember this part? I think you guys answered, right? The birds, when they sit on wires, yeah, they usually sit on the same potential, this thing, but usually I think bats have, one more thing I got to point out. If birds sit with their legs stretched on the wire, on the same wire also, you can see that there's a difference. There's a larger resistance at the bottom when compared to here. Okay, so there are some connections, but my point is, I don't want to speak about this, but in general, potential difference that matters, not the potential. Okay, how much current will flow? Is that fine? Yeah, Asha, I'll try it. Okay, yeah. Now, series and parallel elements. Listen to this. This part is going to be boring, so listen carefully. Okay, I'm warning in advance. There are two possible arrangements. One is parallel and series circuits. So listen to this carefully. If you don't understand this, yeah, bye. Listen to this. This is very important. There are two types of connections. One is series connection. Series connection, by definition, is that between the components, lamp 1 and lamp 2, or R1 and R2, resistor 1 and resistor 2, you guys are starting to solve now resistance problems, actual circuit problems. The most important part of this chapter, that is problem solving. If you do not understand this, you're gone. Okay. So what is a series connection? A series connection is when there's a single wire with no junction. There's no junctions. For example, this is a junction. Okay. For example, if I have in a circuit, if I get this 3 wires connecting a point, then we call it a junction. Okay. No, I'm saying if there were resistors. By the way, lights also offer resistance, right? Light bulbs at the end of the day, that's why they glow. So hope you guys got it. This is series connection. Now, if both ends of a component are connected to each other, like for example here, can you see it? The end of this is connected to the end of the other one. Similarly, the other end is connected to back to the previous one. Can you see this part? Yeah, this is called a parallel arrangement. Is this part fine? Parallel and series. Send me one, okay? If you send me more, I'll kick you out. Yeah, nice. Yeah, Medansh 1S. Yeah, okay, fine, cool. Yeah, now in a series circuit, you must understand, this is the by definition. Components are connected one after the other. This is by definition. Second thing, this is the most important part. There is only one path for the electric current to flow. Is this part fine? Okay, Anish, fine, got it. Now, here's a question. These are ammeters which are connected in series. What will the ammeter say? Will the current be more at A or B? Will the current be more at A or B? Will the ammeter readings at here, A and B, which one will be greater? Yeah, it'll be the same. It'll be the same, guys. It'll be the same. Do not say anything else. It'll be the same. Anish will get kicked out. Okay, he'll be sent out for one moment, just like that, because he likes going to the waiting room. Bye-bye. He's there. Now, just saying, so you have A and B. Okay, two parts to it. So at both the points, okay, do ammeters have a say in anything? Do they have democracy? India wants to know. Good one. No. Okay, now with that being said, is the current flowing through both the resistors the same? Tell me. First question. Simple questions these are. Let's see. I don't know. Let's see. Otherwise, I'll get a lot of annoying messages here. Okay. So, okay. What happens? It's same. It's same. The current is the same. What happens to the current in the circuit if one of the resistors is removed? Will it increase or decrease in the entire circuit? Tell me. Will it increase? Yeah, it will increase. You guys are right. It will end up increasing because the resistor ends up reducing this thing in the circuit. So my point yesterday I was trying to make is the same one. Whenever you have what you say, whenever you have a situation, yeah, Muralidhar, you want to experience it nice. Okay, here you go. You get to experience some of it. Everybody say bye to Muralidhar. I'll come to that 1 second. Okay, done. He's there. Bye-bye. Now, with that being said, so you must understand what happens if one of the resistors removed, the current increases. So yesterday, some of you were saying, what's the purpose of a resistor? You guys were saying, right? Asking that question. What's the purpose of a resistor? Okay. The fact that what do you say? Some of you told me that, see, in a resistor, the electron speed increases. So what does a resistor actually do? You guys are asking me. Now you must understand what's happening here. The resistor's purpose is to reduce the current in the entire circuit. Okay, it reduces the current flow in the entire circuit. It might slow down the electron, speed of the electrons, whatever. But at the end of the current in the entire circuit is dependent on that. Is that fine? Can I get a yes on that? Is that clear? Okay, what would happen? Okay, what would happen, the current in the circuit, if one of the resistors has a resistance that is twice of the other? Will it increase or decrease? Yeah, it will decrease, definitely decrease. It will definitely decrease. That's easy. Okay, now, yeah. By the way, everybody say bye to Anish now. Next. I don't know in the end who will be left in the class, but yeah, let's see. Okay. Bye-bye to Anish, everyone. Again. Bye, Anish. Yeah, there you go. He's gone. Now, the sad part is they can't even talk to each other in the waiting room. Okay. Yeah. At least when you're outside the class, you get to speak with the other person. Okay. In a regular classroom. But anyways, okay. Now going ahead, here's something. So you have, let's say, a battery source that is producing some EMF epsilon. Okay. So I'm producing some this thing epsilon. So I've connected some voltmeter across it, which is saying VE is the voltage across it, or the potential difference, or not the potential difference. Technically, the word is EMF across it. Okay. Now, across resistor 1, there'll be also potential difference. Agree with that? That'll be V1. Okay. Next. Yeah, he has no idea. Yes. Now, here's the thing. Yeah, Shishang, I know. We'll see. So, across resistor R2, I want to know how much is the potential difference, V2. And turns out the relationship is very simple. It just says the voltages get added up. In a series circuit, okay, understand this. This is something you need to know. VE, the voltmeter reading in VE, will be equal to V1 plus V2. Is that fine? Is that part fine? The voltages get added up. Okay, I'll be putting both of them back. Here they are. Okay, so did you guys get it? The potentials get added up. Okay, the potentials get added up. That's the thing that matters. Okay, V plus V, V1 plus V2. So it's basically the total EMF. EMF is equal to the voltage drops. Okay, in a series circuit, in the series circuit. Yeah, done. Next, you have, yeah, I hope that's clear. Can I get a yes or no from you guys? Well, you can't, can you? You can't. Okay, anyways, just saying now. Yeah. So here's the thing. I got your S's now. Okay, fine. Now, going ahead. So in a series, to summarize, this is very important. In a series circuit, the current at every point is the same. Don't forget this. Okay, simple, important. Then the potential differences get added up. So in simplest sense, I can say currents remain the same, potentials get added up. Is that part fine? Does that make sense? In a series arrangement, it's the currents that remain the same, but the potentials get added up. Okay, fine, cool. Done. So with that being said, we'll discuss parallel connection. Now, parallel connection, what happens is the current gets divided. Agree with that? Yeah, hi, Muralidhar. The current gets divided. Is that fine? Okay. Everybody say bye to Amit now. Done. He's gone. Bye. Now, so here's the thing. You have 2 points here. Okay. Yeah. So you see the current gets divided into 2 parts. Is that part fine? Yeah. Yeah, fine. Okay, that part should be very clear here. Okay. Now, next sections. No public chats. Yeah, no public chats. I'm sorry. Yeah, you can't. 1 second. Yeah, done. Okay, now going ahead. Here we go. So you have the current dividing. Okay, I'm getting your messages, Anika. Yeah, I'm getting it. Now I got it. Yeah, will the current divide equally? That depends. We'll come to that. Depends on the resistance. Okay, yeah. Now, going ahead, in a parallel circuit, it's basically said that, what do you say, the components are connected to the EMF of the source in 1 or 2 more loops. So there are 2 extra loops to the EMF, the existing EMF that's there. There are 2 more loops. Is that part fine? Can I get a yes or no? Okay, cool. Second thing, there are several paths for the current to flow. The current gets divided, but the potential remains the same. Is that part fine? The voltage across both the bulbs is the same, but the current gets divided. EMF doesn't get divided. The voltage across both of them is equal to the EMF in this case. Is that part fine? Can I get a yes or no on that? This is basics you need to know. It's just given to you. Okay, it's just given to you. Take my word for it. Series connection, I'm simply saying in one word, series connection. In a series connection, current remains the same throughout the circuit, but what do you say, the voltage gets divided. Here the voltage is same across, not across the circuit, across the bulbs, across the components. Voltage is same across the components, but the currents are different. Current through both of them are different. Is that part fine? Can I get a yes or no now? Yes. Okay, fine. Yeah, that must be clear. Now, I'll get them back. Okay, now going ahead. So we have the situation now. Okay. Yeah. Now, here's a question now. If you see here the current readings, you'll observe that the currents here, in this case, currents get added up. Earlier voltages got added up. Now currents get added up. So I will be equal to I1 plus I2. Is that fine? Is that fine? Did you guys get it? The currents get added up this time. Earlier voltages got added up, right? In the series circuit, V1 plus V2. Yeah. So that's something I want you to remember. It's always a sum. The voltages remain the same, but the currents get added. Is that part fine? Can I get a yes or no on that? Clear? Is voltage different in parallel? No, voltage is the same. Voltage remains the same across both of them, both the components. Yeah, those are right formulas. Nothing is wrong with it. Okay, the current gets divided equally. It has to go somewhere. Remember Kirchhoff's law? Kirchhoff's law. At the junction, the current coming in should be equal to the current I1 plus I2. Yeah, Amit, we can see you. I think so. Yeah. Now, what about voltages? Voltages remain the same. Okay, if you connect voltmeters across all the components, now what we've done is it's a simple parallel circuit. These are additional components that are connected. These, whatever you see in red, are additional components, voltmeters that are connected. The circuit is only the blue one. Okay, that's the circuit that you see here. Okay, nice. Okay, Hail Kirchhoff. Okay. Okay, cool. Going ahead. So to summarize, this is a summary of it. Listen to this carefully. Summary of this. In the potential difference across each branch is equal to the potential difference across the whole circuit. In a yes. So in case of in case of parallel circuits, but whereas the currents get added up. Is that part fine? Of course, Anish, you didn't understand. You were outside the class. Okay. Anyways, read from the textbook. Okay, read from the textbook. Anyways, is this part fine? Can I get a yes on this one? Yeah. Okay, Anish, bye-bye. Done. Okay, now going ahead, here we go. No, he's not outside the class, he's there still. Okay, yeah. Now going ahead, yeah. Now going ahead, here we have a situation now. Let's say you want to replace both the resistors here, which you see, with a single resistor. Instead of having two resistors, you want to replace it with a single resistor. It's a parallel combination, right? The question is, how much should this resistor be? Resistance value V. Okay, that's the question we're asking. Now I want to clarify certain things. Now we'll do a simple problem. Okay, we'll do a simple problem. Listen to this carefully. This problem is very important for many ideas. Okay, let's say I connect a battery EMF. I connect a voltage of around the battery of EMF around plus minus about, let's say, I don't know, 20 volts. And this is gonna be, I think, if I'm not wrong, I think I'll make it, I don't want, this will be made around 18. I'll make this 18 and I'll make this around 9. I will make, this is 9 ohm. This is 18 ohms. And one second, I'll get back to you guys. This will become roughly, let's say, 12 volts. Okay. Now I have some questions for you. You will have to answer now. Okay. Here's the question. Okay. Answer me this. How much is the current flowing through resistor R2? How much is the current flowing through resistor R2? How much is the current? What's the voltage across resistor R2? What's the voltage? What's the voltage across resistor R2? 12 volts, right? That's what's told to you. 12 volts. Agree with that? It's the same. In a parallel circuit, the voltage is the same. We studied that just now. Okay. Now, and Medans gave the wrong answer, obviously, because he was outside. Anyway, now, you guys are right. What is the voltage? What is the voltage across R2? You guys told me it's 12 volts. That's correct. Now, it has a resistance of 9. So how much should be the current flowing through it? How much is the current flowing through it? 4/3 amperes. Agree with that? 4/3 amperes. Okay. How much is the voltage across R1? Okay, guys, one second. I'll simplify this thing. This might be annoying for you guys. I'll go with wait. Sorry. We'll go with 3 and 6. Okay. Tell me. Now tell me how much is the voltage across the resistor R1. This will be easier. What is the voltage across resistor R1? 12. How much is the current passing through resistor R1? How much is the current flowing through resistor R2? R2 will be 4 amperes. Agree with that? Okay. Current flowing through resistor R2 is this thing. What about resistor R1? What's the potential difference across it? What's the potential difference? 12. So how much will be the current flowing through it? Yeah, 2 amperes. So if 2 amperes is flowing through this, 4 amperes is flowing through this, how much is the current coming in? Total current from the battery. What is the total current coming from the battery? 6 amperes. Okay, now I have a question. Understand this. Carefully understand this. These both resistors are acting as if a single resistor in this circuit. If you look at it, it offers a total resistance. Do you see that? The whole thing of it's 4 plus 2. The current branches out, right? Current splits in this thing. Remember that? Yeah, that's why it's 6. Now, one more thing I got to add. Both of them act as if a single circuit. Do you see that? As a single circuit. We had 12 volts here. We had something of 12 volts here. 12. Okay, 12 volts. We have a 12 volt EMF and a current of 6 amperes is drawn from the battery. So how much should be the total resistance in the circuit? Tell me. How much should be the total resistance in the circuit? A single answer, I got it, Keaton. Yeah. How much is it? How much should be the current drawn through how much should the resistance? Oh, I'm so really sorry. I lost feed. Okay. Yeah, I'm there now. Okay, sorry. I lost feed. Can you guys hear me now? Can I get a yes or no? Okay, this is annoying. Okay, what happened to the internet? Yeah, can you guys hear me now? We had some technical issues. I severely had technical issues. Uh, like, yeah. Can you guys hear me at least? I'm trying to connect from a different internet. So I have about, I think, 3 reliable internet connections, but all the 3 have failed here. Okay. Sadly, all 3 are failing for some reason. Bad day. I think 2 of you cursed me for putting it outside. Maybe that's possible. Now, anyways, going ahead. 1 second. Wait, we'll get started. Give me a moment. I'm back. I won't be using my video because, yeah, the problem is there'll be a drain in the internet. So there's an issue. I think Kavya is here. Okay, Kavya is here. Okay, fine. We'll get started. Continuing on, we were on this problem. Yeah, so I was doing this problem. Listen to this. Can you guys hear me? Can I get a yes or no? Okay, fine. Okay, fine. Now, anyways, going ahead. So here we go. We were doing this problem. So can you tell me how much is the effective resistance of the circuit? How much does it act like? How much does the whole thing act like? It acts as if it's a resistance of 2 ohms, right? Do you guys get that? Okay. So my point is a parallel combination. Understand this, a parallel combination of 6 ohm. This is a symbol for it. A parallel combination of 6 ohm and 3 ohm gives you an equivalent resistance of 2 ohms. Fine with that? It acts as if the whole combination of 2 of them acts as if it's a resistance of this thing. Is that fine? Satyuka is here. She's here. Okay. So I'll repeat it one last time. Listen to this. Listen to this carefully. We have a circuit of 12 volts battery and a parallel combination like this, a parallel combination which goes through resistor R1 and resistor R2. Is that fine? Of 6 and 3 ohms. Is that fine? Can I get a yes or no? Okay. Now here's the thing. I asked you how much is the current flowing through I1. How much is the current flowing through I1? Resistor I1. Sorry, R1, resistor R1. How much is the current I1? How much was it? 12 volts across it and 6 ohms. So how much should be the current? Yeah. How much should be the current? Guys, yeah, some of you saying 2. Yeah, it should be 2 amps, 2 amperes. How much should be the current flowing through the second resistor? How much is the voltage across it? You know. So how much it should be? Tell me. Okay. How much should it be? Yeah, 4 amperes. So totally, how much is the current coming into the branch? Tell me. How much coming into the branch? 6 amperes. So my point is 6 amperes is coming to it from the battery of 12 volts. So how much is this resistor acting like? How much is this resistance? Yeah. Just saying that the current flowing through this portion will be 2 amperes. Current flowing through the bottom portion will be 6 amperes. Sorry, 4 amperes. So the total current coming into the circuit should be 6 amperes. Okay. Now, if 6 amperes is coming and this both resistors acting like a single resistor, how much should that resistance be? I'm asking. Turns out, if you put a 6 ohm parallel to 3 ohm, you get a total resistance of 2 ohms. Is that fine? Is that fine? Did you guys get that? Kind of. Okay, I'll ask you a question now. I'll chain things a little bit. I'm going to change the values now. Okay, I'm going to change the values. So I have a resistance. I have a resistor of some value now. I'll connect a battery of some value. I'll change the values a little bit. Give me a moment. I'll repeat. I know some of you went outside. So 1 second. I know some of you lost connections. So I'll repeat. 1 second. I'm going to change the values. Others have to calculate quickly. Okay. How much is the net equivalent resistance? Quickly. This is, let's say, top one. I'm going to give it, let's say, about 2 ohms, and this one will be about 4 ohms. Okay, and the bottom voltage, the voltage kept, okay, the whole thing is kept at a voltage of, the whole thing is kept at a voltage of, at a EMF, with the EMF of about, I think, I'll go with 8 volts. Okay, can you tell me how much is the equivalent resistance? Others, quickly. How much is the equivalent resistance? One second. Yes, got it. No, Nihad, you're right, yes. Okay. Listen to this part very carefully. Listen to this. This is very important here. You have, and this is very important. Listen to this part carefully. Yeah, I think you got it. How much is the voltage across resistor R1? Tell me, how much is the resistance across voltage R1? Eight volts, right? 8 volts. Agree with that? Did you guys get that? The voltage across resistor R1 is 8 volts. Is that what fine? Yeah? Okay, cool. I think most of you are clear with that. 1 second. What is the voltage across? This was discussed earlier. What is the voltage across resistor R2 in parallel connections? How much is it? It's the same, 8 volts. So how much is the current flowing through resistor? Resistor R1? Tell me. How much is the current flowing through it? If you have a voltage of 8 volts and the resistance is 2 ohms, how much should be the current? 4 amperes. How much is the current flowing through resistor R2? 2 amperes. Agree with that? Is this part fine? Okay. So how much is the total current coming in at this junction? Yeah, Keaton, got it. How much should it be? 6 amperes. Fine with that? It should be 6 amperes. I'm asking you, so you must understand, from this battery, we are pulling off 6 amperes. So both of them can act like a single resistor. I can replace this with a single resistor. I'll be still drawing 6 amperes. Agree with that? There's a resistor out there, which if I put here in the circuit, instead of these two, if I replace it with a single resistor, I don't know what that value is yet. If I replace them, and if I put an 8 volt battery, this will still bring 6 amperes current from the battery. So how much should this resistor be? Tell me, it's easy. How much is that? 4 by 3 ohms. Everybody got that? Can I get yes or no? Everyone. Satvika, who lost the feed, and Medansh also. 1 second. Anish, no, seriously. I can't repeat. You missed some portion of the class where it was very important, this one. Where's Murli, by the way? Why can't you guys message me, some of you? That's weird. The setting is host only. I'm the only one hosting here. Amit is like, sir, I can't message you. You can. Yeah, now some of them. Now new ones I think you can send, right? You can get the messages. Yeah, those are gone. Now I think you can message to the other one. Is this part fine? Okay. Do you guys get it that I can replace? So this is a notation for it. Listen to this. This is a notation for it, basically. Okay, many of them have raised hands, so I don't think some of them can even. Just message through this name, guys, if you can see it. Just log in and log out if there's an issue. If log in and log out. Mithul says you have to log in and log out. Whoever can't message me, please log in and log out once. Come back and I'll admit you to the room. That's when you'll be able to message me. I think others can. You know the time when your teacher tells you to go out of the class and go see something and come back, and a whole class goes, even though they don't have an issue? It's like that. Okay. Yes, Sakshi, that's me. You can see the name as Prajwal, I guess, probably, at least. Yeah. Can you guys see me now? Yeah, they've joined. Most of them are joined now. Somebody's asking, who is Prajwal? Thank you for forgetting that I have a name. Okay. After changing the name so many times. Okay, I'll repeat the first problem for some of you. What I'm basically trying to say is, instead of having two resistors, if I want to, I'm asking you, okay, answer me this, check this, answer me this part. This is easy. Okay. And I hope most of you are back. Tell me, if I have a series circuit, if I have a series circuit here like this, this is about, let's say, around 8 volts, and I put a battery, and then I put a resistor. Okay, then I put a resistor. I put two resistors, R1 and R2. Let's say this is about 3 ohms and this is 5 ohms. How much is the current flowing through the circuit? Tell me. This you can tell very easily. 1 ampere, right? Why did you know that? Tell me. You just added it, right? You just added it. The resistance must get added up, right? Simply get added up. That was your calculation. Is that fine? That was the logic which you should have. Whereas, like, you should start paying internet bills. Yeah, I pay them. Okay, apparently I just there's a connection issues for some reason. Okay, nice. Going ahead, is this part fine? Do you guys get it? It gets added up. Now it means that I can simply replace both the resistors with a single resistor of how much? 8 ohms. Is that part fine? Can I get a yes or no on that? Yeah, this is called equivalent resistance, or equivalent resistance, or you can call it some other ways also. But the idea is, if you put them in series, if you put 3 ohm in series with let's say 5 ohms, you get a total resistance of how much? Equivalent resistance of 8 ohms. Is that part fine? I can replace both of them with a single resistor. Both of them together form that much powerful combination. Okay. Now we ask a question. If I were to have the same circuit, but this time if I have a parallel connection, like this, if I have one connection like this and second connection going to the top like this, if I have two of them, let's say, yeah, this is me, Anika. Is it you? Yeah. Okay, this is me, Prajwal. Okay, not some robot talking to you. Here you go. Okay, so let's say we have, this time I put them both like this. Why I have, let's say, about yeah, I told you, right? It's the sum of the resistances. If you put them in series, it's a sum. Yes. Now, going ahead, I think this should be possible. Okay, Anvita got stayed outward. Okay, Anvita was outside. Anyways, but my point is they get added up. The equivalent resistance means that the point I want to make is that the resistances get added up if you put them in series. Okay, they just get added up. But in this case, it's parallel. Like, for example, if you have, let's say, about 3 ohms, don't want 3 ohms. That's a bad number, not a great number. We'll go with 12 volts because it's better. And I'll go with 2 ohms. And I'll go with 6 ohms. Can anyone tell me what's the equivalent resistance? Tell me quickly. Easy problem. Yeah, Satvik, I know. I'll come to that formula. I'm waiting. I'm just taking my time. I'm making sure you guys get the concept. Okay, how much is the voltage across resistor R2? 12 volts. How much is the current flowing through that branch? Tell me. How much is the current flowing through that branch? 6 amperes. How much is the current flowing through the top branch? How much? 2 amperes. So how much is the net current flowing out of the here, this part here? How much is the total current flowing out of this section here? Totally 8 amperes. So 8 amperes and 12 volts. So how much is the effective? Yeah, effective resistance. How much is this totally offering? If I were to replace that entire thing with a single this thing of 12 volts and let's say if I had a resistor, single resistor, how much should that be? 8 amperes. Yeah, 3 by 2 ohms. You guys are right here. 3 by 2 ohms. Is that part fine? So I can say 6 ohm parallel to 2 ohm offers an equivalent resistance of 3 by 2 ohms. Is that fine? Can I get a yes or no? Okay. Now what I'm going to do is I'm going to derive a formula. Some of you know that formula. So I'm going to directly derive a formula to get what is the resistance. Okay. This is a direct formula. Okay. Yeah. Okay. Now going ahead and all this ugliness and my Picasso drawings. Yeah. Now going ahead. Equivalent resistance. You know that I1, I is equal to I1 plus I2. Agree with that? You agree with I is equal to I1 plus I2? Remember that? Remember that part? Yeah. I is equal to I1 plus I2. So, but you know that I1 is nothing but V by R1. Agree with that? V by R1. Voltage across the whole thing divided by the resistance of it. The current flowing through that resistor is V by R1. Agree with that? Can I get a yes or no on that? Everyone. Okay. Similarly, I2 will be nothing but voltage by R2. Agree with that? Okay. But if I do a substitution, a simple substitution, this will give me this. Agree with this? Yeah. Now, based on that, from this circuit, from the second circuit, I know that this is nothing but equivalent resistance will be voltage by the total resistance, effective resistance. Agree with that? Effective resistance that I have to put. Total current divided by, that is, you did earlier 6 amperes divided by this thing. That's what I'm talking about. Yeah. Rearrange that formula, you get this. This here is your formula to calculate how much is the resistance, equivalent resistance. So if you were doing the problem earlier for 1 by 6 plus 1 by 2, this is going to be 1 by R. Remember this? Yeah, 1 by 2 plus 1 by half is equal to 1 by R. Remember this? Yeah, that will give you an equivalent resistance of 6 into this thing 12. This as 8 is equal to 1 by R. Is this part fine? Can I get a yes on that? 1 by R is equal to 8 by 12. So R will be equal to how much? 12 by 8 or how much? 2 by 3, which you guys calculate. Is that fine? Do you guys get this? This is only for parallel. Yeah, this works only for parallel. For series, it simply gets added up. In parallel, it has this very weird relationship. The reciprocals get added up. Reciprocals get added up. Okay, in the linear case, in the resistance which are linear, the directly things get added up. Is this part fine? Can I get a yes or no on it? No, Amit, that won't happen. Okay. Anyways, go ahead. Is this part fine? Read from the textbook. Can I get a yes or no on this? Is this part clear? Linear in the sense, if you connect them in series, I might use a big term. What I mean is if you connect them in series, you get that. There was a question, 1 second. Is an explanation as to why it is it just as is? Yeah, there's an explanation. I'm coming to that. And that explanation is only found in Chabbe, the textbook Chabbe. Okay, I'm going to come to that. Why this formula works the way it is. Why it is 1 by R. Does this remind you of the Lenz formula by any chance? Oh, sorry. It is 3 by 2, not 2 by 3. Sorry, I wrote it wrong. But you get the point, right? It's the same thing. Yeah. If I don't know whether you can see it, it has some connections to what you say, your Lenz formula, 1 by U plus 1 by I is equal to 1 by F something, some sort of relationship. These reciprocals come up in many reasons, many places. So it's going to be 3 by 2. Yeah, you guys are right. 3 by 2. That's just a typing error. Now, in general, if you have many resistors parallel and you want to replace it with a single resistor, then it's simply going to be this formula. 1 by R1 is equal to the reciprocals of all the resistors which are there. Is this fine? All the resistors. So this is called the, and one more thing I got to mention. In a parallel circuit, listen to this, the effective resistance or the equivalent resistance is always smaller than the smallest individual resistance of the circuit. What I mean is when you put parallelly 6 and 2, how much did you get? What is the equivalent resistance? 3 by 2, right? If I'm not wrong. And 3 by 2 is 1.5. Agree with that? Can I get a yes on that? Yeah. I don't know if you notice this. This is smaller. This resistance is smaller than the smallest resistance in the circuit. Yeah, Kavya is having some issues. Do you see this is a, agree with that? Did you guys get it? Chabbe, Sherwood Chabbe. Okay, matter and interactions. Okay. Now, is this part fine? Can I go ahead? Is this formula clear? It's derived. Just take my word for it. The formula exists. If you have parallel connections, many of them, you can replace them with a single resistor. Okay, fine. Going ahead, and this is important. Okay, calculate the currents. Answer this. 1 second. Why then isn't so many resistors in parallel kind of pointless if the resistance is going to be low? Sometimes we want resistance to be low, Nidhi. We want to reduce the resistance of certain things, and we take advantage of these things. I'll come to this. You'll see the advantage of these things. But out of mathematical curiosity, it's fun. Nah, I'm not going to derive it, Anish. I'm sorry. Once. Later. Let's see. How much is the total current flowing? Tell me. I1, I2, I3. How much is I1? How much is I2? How much is I3? It's very easy to calculate. Okay, first tell me how much is I1? Yeah, we might have to use parallel. So why its advantages is, let's say you want to use you're not getting a resistance of, in the market, if you go and buy resistors, let's say you're not getting a resistance of 0.01 ohms. You can't get it, let's say. How do you create one? Put something in parallel, reduce the resistance. Got it? Put a bunch of resistors in parallel, which you can get, and somehow achieve that resistance. So there are some advantages like that. Okay, you guys are calculating. First one is easy, 0.6. 6 volts across the whole thing, and the current will be just 0.6. Is that part fine? Yeah, this is part fine. Okay. Similarly, I1 will be 0. This thing. What is that? 0.3. And the total current should be 0.9. Can I get a yes or no on this? This is the basics of the formulas you need to know today. Okay, equivalent resistances and those calculations. Those are very important, because you won't understand anything beyond this point if you don't understand parallel combination and series combination, because there'll be a lot of complicated problems coming in. Okay, I think we lost Shashank. 1 second. Yeah. Okay, going ahead. Now there's an awesome demo. I will go ahead with this. See, I understand in the beginning there'll be a lot of doubts. Okay, but as time progresses, things will become much more clear. There'll be a Paul Hewitt's demo tomorrow. I'll be doing that tomorrow. I'm sorry I lost some time today. There's some internet issues. There were some internet issues. I'm right now using my dad's internet, phone internet, so that's how it's working. But anyways, I think I even lost my internet completely. Anyways, I think that's it for the day. I will continue with this thing. What is that? I think I was planning to do this thing. Yeah. What is that? Previous slide. You want to see the previous slide? Okay, here you go. Angular magnification. I'm doing the angular magnification thing now. Yeah, I know. I'll use different words for Shashank, so it's fine. But as long as it doesn't lead to any confusion, I think it's fine. I'm doing the angular thing. Yeah, I'm doing it now. Can you give a hint for the 7th question in the 17 question number 17 in the DPP? How did Anish land in the waiting room without me kicking him out? Nice. Okay, that's fine. Okay, I'll do optics review now. I'll be doing it now. I just meant I'll be ending the class. Okay, now the optics review. So I just want to I'll take questions now. Yeah, bye. Whoever wants to leave can leave. Okay, I'm doing an optics review. Not a review as such. I'm doing angular magnification review. I'm going to take questions and understand and probably explore them. Okay. Can you give graph? Explain the graph of yesterday's class. Which graph? That graph is not so important, so don't bother with it. Okay, just don't bother with it. I'll take some time to explain, but it's not that super important that you need to remember it. Okay, just saying. Okay, this is what happens when you take two screens. Yeah, not exactly that. That's not the reason why this happened. Can you repeat the formula? Add issues, hotspot issues. Okay. This is this thing. I'll just show you the page. Yeah. Okay, Nidhi has a question. Angular magnification plane mirrors. How image size is only half the image is only half the image size. Okay, I'll come to it. I'll come to these things. So I think some of you have confused certain things about angular magnification. I'll go to this. I won't do the derivation. I can't. Amit, you lost time. So read on your own from the textbook. It's a very important derivation. It's definitely coming for the exam. I'm warning you now. This, whatever I did, when you were in the waiting room, whatever I did was very, very important. Okay, I'm not going to do it at all at any cost. Okay, anyways, going ahead. I'll just do the optics thing now. I'll just end this 1 second. Yeah. The derivation of this thing, what is that? The parallel and series connection, that's what I'm talking about. The derivation is very important. Okay, going back to optics now. We'll get back to optics. I'll stop sharing the screen. I'll be switching to 1 second. Where are we at? Okay, 1 second. Okay, going ahead. So this is the optics review. Yeah, the formula is applicable only for a parallel circuit. Just want to say, effective resistance, equivalent resistance. That resistance you can resistor. You're gonna the resistance of the resistor that you're gonna replace instead of that entire combination. That's called equivalent resistance. Okay. Now going ahead, I want to go with the optics thing which we were dealing with. So can you guys see the presentation? What if the object is placed at infinity and all that stuff? Okay. What if the object is placed at infinity in front of a plane mirror? I'll come to that. I'll come to all the things. First, I'll do a review on this thing. First, I'll do a short review. This is the entire optics PPT. It's lengthy. 1 second. Take some time for me to finish it. Okay. 1 second. Now, where I put it? The angular magnification. Okay, just want to start with this. This is something you're familiar with. Do you guys remember this? Can I get a yes or no? Okay, this is in your DPP. Okay. Yeah, you know, this crossed about 300 slides. The entire presentation was 300 slides. Now, here's the thing. So we have this picture, famous picture of Bohr stealing the Gamow cycle, okay, and riding it off. You know George Gamow, right? The guy, I think, Big Bang guy, Big Bang Theory. Responsible. That guy was responsible. So they went to his house and they were having a party, and Gamow steals the bicycle. This guy, Bohr, takes the bicycle and straight away goes with his wife. This is Bohr's wife. Okay. This guy running with the bicycle behind to catch up with the motorcycle. Something. Okay. Anyways, so if you look at it, I don't know whether you realize this. Okay. I'm at slide number. Can you guys see the slide? Can I get a yes or no? Because Shashank is saying I'm on page 227. No. 253. This one, from your eye point, which does Bohr circumference cover your eyes? How much? Is it less or is it more? Do you agree that it's more than this person, even though they're of the same waist size? I bet that person is not very much fatter than Bohr. Agree with that? Both are almost of same size when it comes to their fatness. Yeah, but you see, in your vision, you will see that you will end up covering more of your vision. This Bohr will end up covering most of your vision. Agree with that? Do you guys get that? Okay, so what captures that size? That Bohr captures most of your this thing. How does that matter? So here's the important idea. If you look at it, I don't know whether you can see this. See, Bohr might cover almost 40 degrees of your vision, angular size. It might cover 40% of your vision. Okay. Whereas this person has the same length of arrow, same length. The arrow length is the same. Can you see that? The arrow length is the same in both the cases. Do you guys get that part? The arrow length is the same. The waist size, the person's actual size, the waist size is the same, but the waist that it covers in your vision is smaller, and that can be captured just by the angle it makes with the eye. Do you see that? Do you guys get this part? The angle matters. The angle that it makes with the eye matters. Is this part fine? Okay, Nidhi, I want you to try an experiment today. Okay, we'll discuss that in some time. 1 second. So just remind me of this experiment. Okay, I tried this. This was fun. So we just wanted to confirm if this theory is right, and we performed this experiment. So this is an important takeaway. Moon and your thumb, like there is some example that's given. So if you put your thumb right in front of you, and let's say you cover the moon, let's say hold the thumb facing the moon, and if the thumb completely covers the moon, we say the angular size of your thumb and that of the moon is the same, because it covers the same portion of your vision as that of the moon. Is that fine? Do you guys get that? I'm saying if you were to place your thumb here, somewhere here, and there was a moon, we would say the size, angular size of the moon and the thumb is the same. I understand moon is much more further. Is this part fine? Do you guys get this? Okay. So in general, I think I mentioned this. The angular size matters. Angular size matters. So when we say we want a magnified image, we care about angular size. Now I would just want to add something. I don't know whether you see this. This is an image that was there in the DPP. So if you look at it here, you can't even read. Can you even read the word silk in this? Of the size makes up the large distance. I didn't get that. I'm sorry. Okay, but can you even read the word silk in this, in the second one? No, but when you think about it, can you see even the dot in the silk? Dot of the silk, the dot of the I, in this case. You can't, right? Almost, but in this case you can see. Why can you see it? Tell me, what made the difference between these two? What is it? The angle, right? How much of your vision it covers matters. Do you see that? Do you guys get that? There's a larger angle that makes with the eye. Now, for example, on your retina, earlier, how many cells were occupied? Let's say to capture that letter I, let's say 50 cells were occupied. Okay, I hope I can use pens. Yeah, let's say about 50 cells were occupied, just 50 cells in the retina here, 50 cells. But in this case, now to cover that same eye, about 100 cells have been occupied. Agree with that? A little bit, at least more than that. Agree with that? So now you can see the details in the eye. You can see the details in that letter I. Like here, you can't even see the dot in the eye. Do you guys get that part? So increasing this angle means getting magnified. Agree with this? Going from a smaller angle to a larger angle means magnification. Is that part fine? Is that part fine? Okay. Okay. Hope that's clear. So you guys got what angular size means, right? Angular size of an object. So increasing the angular size is a priority. So if you want to magnify something in your life, or you want to see something magnified, it's all that matters is you increase that angle. Bigger the angle, better the image. Is that part fine? Can I get a yes or no on that? Okay, whoever is there. Okay, fine. Now, how can you increase the size? Now, there are many options. One is, what do? Get the object closer. Is that part fine? One, you get the object closer. Yeah. Second option is, make the object bigger, like this. Make the object bigger. But increasing the height of the image is not possible. Yeah. Less distance, more height. Yeah, the priority is you have to make the distance less and increase the height. But increasing the height is not possible. But you know of certain things which can increase the height of something. Not increase the height, but you can somehow increase the height of its image and then start seeing it. Got it? See, you can't increase the height, you can't make boar fatter, but you can use a lens which can make boar become thicker, like appear fatter in your this thing. Agree with that? You can, yeah. Did you guys get that part? There are some optical devices out there which can increase the height of the image, and then you can see that image. That will make you see a larger, you can see the object in a bigger size. Okay, if that part is clear now, this is exactly, actually I'm actually summarizing the DPP here. The DPP has everything here, the step-by-step problems what I'm talking about. Okay, now I don't know whether you realize this. Now you might say, see, there's a way to magnify now. Now I'll just go to a white screen. I'll just use my whiteboard. 1 second. I think I have my whiteboard somewhere here lying around. I hope it works. I really hope it works. Give me 1 moment. It'll take some time to load. This is great. That's it. 1 second. Okay. Can you guys see my whiteboard right now? Can you see the whiteboard? Now, is it visible? Yeah, okay, it's visible. Now let's say I have some sort of what to say? Yeah, okay. So let's say I have some sort of tree or something like that. Some tree. I don't know, not tree. Let's put a chicken. Okay, let's put a big chicken. See. Okay. Now the height of the chicken, let's say, is about roughly about, I think I'll give it about I don't know, 20 centimeters or something, some height. It's kept really far from my eye. This is my eye. This is my eye. I'm seeing it from here. This is my point of where my eye is. Okay. Now, what is the angle it makes? What is the angular size of this? This angle right here, right? Theta. Agree with that? Theta is the angular size. You guys agree with that? Okay. How do you measure this angle? Can anyone tell me? If I give you this distance as around, let's say 100, how do you measure this distance? If this is 100 centimeters and if this is 20 centimeters, how do you measure this angle? You guys know tan theta, right? Tan theta is how much? In this case, tan theta is how much? 20 by 100. Agree with that? Or equal to 1 by 5. Then take tan inverse. Theta is tan inverse of, tan inverse of, you can measure this, tan inverse of around 1 by 5. So that will give you the angle. Okay. Now, how can I increase the height? What can I do? Let's say I bring the chicken closer. Oh my God, I can't erase this like this. This is how erasers work here. Okay, fine. So let's say we have the eye again, the eye. And earlier it made an angle of roughly about, you guys remember this angle. This is my theta I, initial angle, okay? Now I get the chicken very close. Let's say I get the chicken close to about a distance of about, let's say I get it to around 20 meters, 20 centimeters. Okay, now tell me what is the angle made by the chicken. This is very easy. 20 centimeters in height, 20 centimeters is the distance. How much is the angle? This is very easy. Tan inverse of theta f is, final angle is tan inverse of 20 by 20. How much is that? 45 degrees, right? Did you guys get that? Can anyone calculate what is tan inverse of 1 by 5? Oh, I'll have to open my calculator otherwise. How much is this? Roughly give me a value. 11 degrees. Okay, I'll take it as 10 degrees. Is that fine? Okay. Now, it's 11.3, I know. Okay, thank you. Yeah. So I'll go with 10 degrees roughly. Okay, 10 degrees. So in bringing the chicken closer, how much did angular magnification did I achieve? Tell me. Roughly 45 by 10 degrees. Agree with that? Theta f by theta I, initial angle by final angle. So you see, I achieved a magnification of 4.5. The chicken is 4.5 times bigger in my retina. Did you guys get that? The ratio matters because you went from how much to how much matters. It's now occupying 4.5 times the size in my retina. Did you guys get this part? So how do you magnify an object? Get it closer. One way is get it closer. Is this part fine? Okay. Now I'll speak a different strategy with you guys. I'll try a different strategy. Okay. What's going to happen is I'm going to have the same chicken. I'm going to do a different way. Now this is an experiment I want Nidhi to conduct. Okay. Whoever has a lens can conduct this. She was doing some experiments, so I just mentioned her. What I'm going to do is I'm going to do something crazy now. So this is my eye. This is my eye itself still this is my eye. I'm going to do something different now. Let's consider this possibility. 1 second. I have an issue. 1 second. Yeah. Now let's consider this possibility. Let's say instead of by using some device, let's say I place a device here which does something amazing and places a chicken here. Chicken comes here and becomes bigger like this. Okay, let's say place a chicken inverted there somehow. I'm not still telling you what is it. Is a device. Let's say it's a lens. Okay. Let's say it is the focal length of this lens. Calculate this quickly. Okay, it's easy. Focal length of this lens is around 10 centimeters. Okay. Object height is 20 centimeters. And so object is kept as 20 centimeters also. Okay, it's kept at 20 centimeters. Or I'll make this not 20. I'll make the chicken height to be only 5 centimeters. This object, whatever, is not chicken. Okay, anymore. So can you tell me where's the image form? Where's the image form? It doesn't matter. Where's the image form? Yeah, 20 centimeters. That's easy. Yeah, so you guys know that this is 20 centimeters. Okay. Now tell me, let's say the distance from the lens of the eye, let's say eye is situated such that it is at roughly about 10 centimeters. Sorry, 30 centimeters from the lens. Is that fine? Yeah, fine, Amit. Yeah. Let's say it's placed at 30 centimeters from this thing. Let's say eye is placed at 30 centimeters. Is this fine? Can I get a yes or no? Then how much is the distance between the new chicken formed? Let's say this is a new object, not my chicken. It's the same height, I agree. Yeah, I get it. Yes, Nidhi. Now, so the chicken is suddenly magnified to the eye. Yeah. If you look at it now, how much is the height of the chicken? How much is the height of the image of the chicken? 5 centimeters itself. That doesn't change. Agree with that? It's inverted, but the height doesn't change in this case. Okay. Now understand this. This part is important. The distance to the chicken is now 10 centimeters. Agree with that? Image of the chicken. Earlier, how much was it? Tell me. Can anyone tell me how much is the distance earlier? How much is the distance earlier? 30 plus 20. How much is that? 50. So how much was the angle made? 5 by 50. How much is that? Tan inverse of theta initial. How much is tan inverse of 5 by 50? Tell me, somebody. Theta I, initial angle. Roughly 5 degrees. Yeah. Wait, I'll come to that. Yeah. Tan inverse of, yeah. Roughly about 5 degrees. Is that fine? How much is it? 3.5. Can anyone calculate for me properly? 5.7. Okay, 5.7. Okay, it's 5.7 degrees. So I'll take it as 5 degrees. Is that fine? Can I get yes or no? Can you tell me how much is the angle now made by the chicken in the vision? It's at a height of 5, but the distance is only 10 now. How much is it? Theta F is how much now? Tan inverse of? Yeah, roughly, I know, roughly. Give me a rough estimate. Oh, 26, okay. It's exact 26.5. Okay, I set it that way. It's 5 by 10, yeah. Roughly giving you around 26.5. So I'll take it as 25. How much is the chicken magnified to me now? M theta. What is the angle of magnification? 5 times, right? Did you guys get it? Can I get a yes or no on it? So my point is, you can get magnified. Now I have a question for you. What if instead of placing my eye at 10 centimeters, I placed it at 5 centimeters? If I placed my eye at 5 centimeters distance, what would be the magnification? What would be the angular size? Tell me at least. Instead of 25, how much will it be? If I kept the eye just at 5 centimeters from the image of the chicken, how much would be the theta? Theta F, final angle. 45, right? This is easy. 45. How much is the magnification now? About 9 times. So you achieved 9 times magnified image. What if I come much closer? Let's say I come just about 2 centimeters. Tell me, how much is it then? 2 centimeters. 5 by 2, how much is that? Roughly, how much is the angle? Yeah, tan inverse of 5 by 2, can anyone calculate how much is that? Roughly 68. Okay, 68. So you know how much it is. 68, roughly about. Oh, Sakshi, I'm sorry. You can't hear me. Okay, just try getting connected. Okay. What if this was roughly only 1 centimeter? How much was it? Roughly 14 times. So you see, you can go on magnifying just by going closer and closer. Do you agree with that? By going closer and closer to the image, you don't have to go closer to that chicken. You know you'll get bit in the eye. Chickens are not safe very close to the eyes. You agree with that, right? Yeah. So they would love to kiss your eye. Okay. So you know that really well. So you can magnify the image just by going closer and closer to the image. But then I told you there's a problem. What's the problem? You can't go closer and closer to the image because of the near point. It appears blurry because the eye has a near point. You need to keep an object at least 25 centimeters from the eye. Agree with that? You have to keep the object at least 25 centimeters from the eye. That's the problem. So I want you to try this experiment, Nidhi. What you do is, anybody who has a lens in the house, try this. Take a single lens, keep the object at 2f. You'll get an image, you will get one more image at exactly at 2f. You agree with that? There'll be an image formed in front of the lens at 2f. So take your eye, take it closer and closer. Take the eye and try to go closer and closer. Okay? See if the object gets magnified. If you have a magnifying lens. Oh, by the way, how to find the focal length? Just see the distance at which the object becomes the highest magnified. Take the lens, go further and further away from the lens. At some distance, you will see that the image gets suddenly blurry and stuff like that. So that will be the focal length roughly. Okay. Now, Sakshi, what I was just saying to say is, if I have a lens and if I have a object, and if I, let's say, form its image here on the other side of the lens, then if I get my eye closer and closer to it, I will be getting larger and larger angular sizes. So in the sense, I can magnify an image just by getting closer and closer to the image. Is that part fine? Do you guys get it? Okay, everyone, just giving me a rough picture that you guys have understood. Whoever is there. Okay. Okay, now for questions. There is still more. Actually, there I can go more. I can speak about how a magnifying glass works and all this stuff. I think I told you, right? In a magnifying glass, there's a problem. In a magnifying glass, I'll just add one last thing, which I discussed in the class, but I don't think I cleared it up. What I'm just going to say is, in a magnifying glass, what does a magnifying glass basically do? So if you look at it, if you have a magnifying glass, in the normal scenario, if you were a normal person, and this was your eye, this is your eye, and this is the near point, let's say, this is a near point. You couldn't see anything that is brought within inside it. Agree with that? Can you see this object? Will it be blurry or clear, this object? Yeah. Is it blurry or clear, this image? This object, which I've kept? It'll be blurry, at least not comfortably, you can see it at least. Okay. Now, what if I introduce a lens in front of the eye, okay, such that if I have this object placed here, this object is placed at the same point, it will be blurry. If I place a lens, what will happen? If it is within the focal length, this object is within the focal length right now, agree with that? It'll create an image which is away from the object, agree with that? Did you guys get it? Okay, now I have a question. Has this object actually been magnified? Let's say the eye is here itself. Let's say the eye is very close, very close. The eye is here only, at the lens. Eye is at the lens. The eye is at the lens. I have a question. What is the angle? Let's say, look, I'll try to quantify as much as possible. Let's say this focal length is 10. Focal length is 10. No, not 10. Don't. I don't know. In the DPP, I've done it really well. I'm sorry. The calculations are proper. But my point is, let's say it's at some distance. Now, this object, do you agree that this object is placed beyond the now? Do you agree that the object is now placed beyond? Did you guys get that? The image is placed way beyond the focal, the near point. Agree with that? So is it going to be blurry now? Tell me. Is this going to be blurry at the end of the day? No. Now I have a question. What about the angle made with the eye? Has it changed? Look at the object. Look at the image. New image form. Is the angle changed? No. So my point is, the angle hasn't changed much. Yeah. I'll come to that. The angle hasn't changed, but here's the thing. Earlier, the object was kept at the near point. Agree with that? Object was kept at the near point to get a clear image. I'll call this theta I. This is you getting a clear image. That was the angle you were getting it at. Let's say if you keep it here, you got an angle of, let's say, about 20 degrees. Is this fine? Okay, clear image at the near point. Okay, now when I introduce the lens, obviously the angle will not change. Agree with that? Theta f won't change. Still it's 20 degrees. Agree with that? Now, when I keep it at the near point, it's still not blurry. Agree with this? Can I get a yes or no on this? Okay. Now, let's say I get the object nearby. I'll get the same object much more nearer. Where is the image form? Tell me. Where is the image form? Wait, I'll come to that. Image is not magnified. Wait, image is not magnified. I got the image closer. Where is the image form? It's formed much closer, but it'll be still larger. Agree with that? It'll be this. Agree with this? It'll be the virtual image form. Agree with this? Okay. Now look at the angle it makes with the eye. Look at the angle it makes with the eye. Is the angle greater now? First of all, is the image blurry? First of all, is the image blurry? Look at where the virtual image is. Is it beyond the near point? Is it beyond the near point? Yes. So is it clear now? Tell me, will it be clear? It's not blurry. But did I get the object closer? So what is the angle now it makes because of that? What is the angle of the image also? Image makes the same angle as the object, right? Which you've seen. How much is it? Roughly about 40 degrees. Yeah. So what happened is this magnifying glass let you bring the object much closer, thereby you ending up magnifying the object. So the theta I by theta f by theta I, if you do it, how much is it now? 2 times, right? Agree with that? You ended up magnifying roughly about 2 times. You got a larger angle. Got it? It will let you get the object much closer. It can get it up to the new near point which is created. Is this part fine? A magnifying lens basically ends up magnifying some object by allowing you to get the object close to the near point. So it appears magnified. Can I get a yes or no on this? Or is it clear? No questions. Okay, that's why we say call it a magnifying glass. It magnifies. I'm not saying a magnifying glass does not magnify. A magnifying glass magnifies. What about shifting the near point? That's what I'm trying to say. You can get it much closer now. You can't get it very close. Like if you get it very close, at some point the images form inside the near point. Then it's blurry. Then it's again blurry. Okay, so you can get it up to that point. So how do you measure the magnifying power of a glass? This is how we do it. How do you measure the magnifying power of the glass? Simple logic. What you do is you calculate how much is the angle made at the near point. How much is the angle made at the near point? Okay, you get the angle, right? That is the near point angle. Then you see how much closer you can get it. Okay, how much closer you can get it. That angle made divided by the actual initial angle where you got the blurry clear image will be the magnification of the magnifying glass, because it did lead to some magnification. It let you got it, bring it closer. Okay, why does the image Niyadas, why does the image magnify when you put the object in front, object far and keep? Yeah, that's what I think I tried to explain last time. Why do you see magnification when you keep the object further? Okay, when you keep the object further, I think I explained this. If you're using a magnifying glass and if your eye is really far, let's say your eye is very, very far, and this is a magnifying lens and this is the object. Okay, if you're looking at the object directly, it makes a very small angle, let's say 10 degrees. I'm going to explain quickly this thing. Let's say it makes just an angle of 10 degrees. But here's the thing, when you introduce the lens and the eye is really far, let's say eye is really far, let's say about 10 centimeters, then it makes a larger image. Agree with that? The angle hasn't changed. The angle with this thing hasn't changed. It's still, let's say 30 degrees. But with the eye, it makes 10 degrees. Is this part fine? Because of the distance. Okay. Now, when you look at the angle of the object made. Earlier it was 30 degrees. Now, how much is it? Because of the heightened image of height of the image. Will it be greater? Roughly about 20 degrees. Agree with that? Yeah. So you went from 10 degrees, initial angle of 10 degrees, because you were really far from the object. You went from 10 degrees to theta f of almost about 20 degrees. So how much is the magnification you achieved? 2 times. You achieved 2 times magnification, roughly about 2 times magnification. But here's the problem. Here's the thing. Still, it's not high as how much you would have got if your eye was here. If your eye was here, you would have got 30 degrees. So coming closer to the lens is what matters more than this magnification, where you keep the object, where some of you use the lens, right? By keeping it very close to the object. That's not the right way. You have to get the eye to the lens. Okay. Is this part fine? Can I get a yes or no? Yeah, sure, Shashank. Bye-bye. Yeah. How does angular magnification work in mirrors? Okay, this is the last part, I think, the question part. Okay. Okay. So how does it work in mirrors? So if you have a mirror, it doesn't change much. Okay. So angular magnification doesn't contribute a lot in terms of mirror. Can you describe the situation? I'll let you turn on the microphone. Can you describe what you're getting at, maybe? Yeah. Tell me where's the eye placed and I'll draw accordingly. Oh, okay. So I'll go with this. Okay. So let's say I'm assuming, help me with this, assuming you're dealing with a curved mirror, because my drawing is not that great. Let's say I have, oh my God. Okay, wait a second. Where is the scale? Yeah, there you go. 45 degrees, rotate the whole thing around somehow. It's a plane mirror. I got it. I know it's a plane mirror. My drawing skills are not that great. Okay, that's what I was trying to get at. Okay, I hope this is going to be fine. One second, I'll answer your question. Let's say we have a mirror. Okay, I'm just going to draw some lines and accordingly, let's say this is a mirror. Okay, it's curved, it's fine. Now, let's say we have an object placed. We have an object placed here. Okay, this is the object. Okay. Now, if this is my eye observing it, let's say my eye is even further than the object. Let's say my eye is even further than the object. Let's say my eye is somewhere. Once again, I'll take the charts to the other side because it's annoying me. Okay, let's say this is my eye, seeing it. This is my eye. Okay, and I'm looking at the object. Let's say it makes an angle of roughly about, how much angle do you want? 20 degrees. Okay. Now, where is the image form? Tell me, where is the image form? in the plane mirror? Inside the mirror, right? Agree with that? It's a virtual image. Yeah, behind it. So it's going to be formed at the same distance here somewhere. Okay, of the same height, of the same height. Is this part fine? Okay. Now, when you look at the image, how much is the height? Tell me. Will it be lesser or small, greater? It'll be lesser. So roughly about, let's say about 5 degrees. So did you get any magnification or did it become smaller in your eyes? So you became smaller. So my point is, a mirror always shrinks you a little bit, okay, in the eye retina. So if you look at yourself in the mirror, you appear to be further than where you are. Agree with that? It pushes you away. Any object, it introduces distance, right, between you and, like if you are 5 centimeters from the mirror, from your own image, you will be at 10 centimeters. Agree with that? You'll be seeing it much further, the world. Okay, Nidhi says, but you seem to, no, I don't think you appear the same. No, you appear the same if you're looking at yourself, because you're looking at yourself. Take an object, take a pen and place it in front of you and look at its image in this thing, same pen's image. Take a pen and keep it in front of you. Obviously, this will be bigger to your eyes. That's what I meant. Got that part? Okay, yeah. So that's my point. So this always explains this angular magnification concept, right? I was skeptical, maybe this doesn't explain something. Turns out it explains literally everything you can see in optics. It makes sense that objects become larger, smaller, why they get blurry. It explains because of the distance and all this. Distance changes. Okay, I'll tell you why distance matters. Distance determines whether things are blurry. Okay. Angular magnification determines the size. So we care about both the things, and so we have to play around with these things. Anything else? Any other questions based on this? Try the experiments, please. Okay, sir, you didn't discuss C of the message. Okay, 1 second. Some part, magnifying power of the and focal length of the combination of lenses. I discussed that part of the chapter long back. I discussed the combination of lenses, but I said I'm not. Yeah, I discussed that while I was doing that. Okay. I'll just tell you in simplest terms. Magnifying power of the lenses is much more complicated. 2 of them. Question B: image distance is taken as. I think so. Eye distance is always. Which one are you talking about? I can't see the. 1 second. I'll just go through and try to find my. Yeah, 1 second. I found it. I think you guys are talking about. 1 second. I'll just get back to this. You guys can see the DPP. Question number 6B. Yeah. It's a continuous problem. The problem is continuous. Okay. It goes on, and I think object is placed k centimeters. It depends. Object is placed k centimeters from this thing. Image distance, yes. That's the point. Image distance is always 2.5 for this problem. Okay. Yeah. Now, Sumedh, you were saying, yeah. 1 second. I think I discussed that part. Yeah. 1 second. In the telescope, it's much more complicated how much magnification you get, because again, you have to take into account the near point. Okay. That's much complicated. I thought of deriving the telescope magnification formula, but I suggest you guys go online and look into them. You will see some version of tan theta and tan theta being used, but they'll use an approximation because objects are really far. They use tan theta is approximately equal to theta, because objects are really, really far in case of a telescope. So the angle made is like very, very small. So they'll simply go on to say theta is equal to almost tan theta. So they can write the distance as simply the image distance by the distance of the object divided by its height directly. Tan theta is that, right? So theta can be written directly as h object height divided by I. They're going to do an approximation. That's it. Okay. Nidhi is like, if you see yourself in the mirror, you see yourself. Oh, by the way, Sumedh, it's not there in the textbook. There's no derivation in the textbook for that. Don't worry. That's in the miscellaneous section, advanced section. It's not there. Okay. It's not compulsory to write. It's not compulsory to write the whole DPP. Okay. It's not compulsory to write the whole deal. Only level 1. Okay. If you see yourself in the mirror, you see yourself to be the same size, even though your image in front of the mirror is further away. Wait, first of all, Nidhi, can you see yourself? You're seeing what a person would see if you were standing 2 meters away from you. When you're seeing something in the mirror, you're seeing how a person would see you if you were standing at that same distance from you. Is that fine? If the person was, let's say, about 2 meters, or let's say the image distance, let's say what you were, that's what the person sees. Is that fine? Okay, I think I'm guessing you're typing a question right now. Follow-up question. Okay. I'll explain it this way. Okay, this might work. This is simple to explain, not difficult thing. So I'll just explain it. With the telescope thing, it's quite complicated, but I think this is explainable. So when you're standing, let's say this is a mirror. Okay, again a curved mirror, and let's just say this looks like a mountain, steep mountain or something like that. Anyways, so let's just say we have, let's say this is Nidhi standing in front of those things. Okay, now you're going to be looking. Oh, you guys can't see the whiteboard. Okay, sorry. You should have told me. Thank you. So you can see how bad the mirror is now. Okay, you can appreciate its beauty. Now, let's say this is Nidhi's eyes. Okay, this is Nidhi's eyes now here. She's viewing from here. Now, if you look at the angles made, so the image of Nidhi is formed here itself, if you agree with this, same distance. Okay, now let's say if somebody was standing here at exactly this distance, let's say this is about 10 centimeters, I don't know how close you can stay, but let's say 50 centimeters, and this is 50 centimeters. And let's say somebody was standing behind you at around 100 centimeters. Okay, fine. Now, Nidhi's eyes will make an angle with the, agree with that? This is the angular size you're seeing, some roughly, let's say about around 20 degrees. Is this part fine, Nidhi? Is this part with others also fine? Okay, 20 degrees. Now, so it makes 20 degrees in your eye. Okay. Now that's the size you see when you see what to say, your image in this thing. Now, if somebody were to stand here and here, let's say somebody were to stand here, this is, let's say, somebody behind you, let's say it's my ghost, okay, Prajwal's ghost, standing there behind you. Yeah, standing there. And let's say I'm standing behind you for some reason. And what is the angle you would make? Tell me, easy calculation. How much is the angle my eye would make with you? What is the angle you would appear in my retina? Tell me. Calculate, it's easy. 100 centimeters, same calculation, 100 centimeters. What's your height? Let's say about 20, whatever that is. Your height is the same. Do you agree your height is the same in the image and the object? Agree with both are same? Okay. Distances are the same. It's 100 meters itself. 100 centimeters itself. So what will be this angle? 20 degrees. Agree with that? It will be 20 and 20. Both will be 20. Yeah, the image seen by you, yourself in the mirror, is the same as somebody would see if they were standing 100 centimeters away from you. So you're seeing yourself in the mirror as somebody would see you as you were about, I think, 100 centimeters away. So you are actually placed further away without increasing your height or anything. So mirror actually hasn't magnified you because there's no way to compare. You can't see yourself. So there's no concept of magnification because you can't see yourself, right, directly. Is that fine? You're seeing it's, yes, I understand you're seeing an image, but that's the only thing you can see. But for a person, okay, for a person seeing you, you have shrunk significantly because now you're 200 centimeters away, but with the same height. Is this part fine? For me, for Prajwal's ghost, you're shrunk significantly. There's a minimization of the image. You're much further away. Is this part fine? So the angle never changes. The angle, I'm saying if Prajwal's ghost was standing at around, let's say about 50 meters, then the angle would have been greater than that. Okay, the angle would be something like just very small. If you're standing at just 40 centimeters, the angle could have been about 40 to 45 something. Okay. I'm saying just understand the angles made with things. Then you'll get an idea. So when you use a camera lens, I don't know whether you do photography, but if you move the camera lens, you'll see some magnification, zoom effects and all that stuff. What's exactly happening is it's playing with the angle of magnification. It's just playing with the angle of magnification, giving you a feel as if you are going closer to the object and seeing it. That is what zoom basically is. Zoom means basically you're going, it gives you the feel that you're going closer to it. Whenever you use zoom in a, let's say in anything for that matter, it gives you the feel that you're going closer and closer to it. Actually, you're not going closer, they're just increasing the angle of magnification. It creates an illusion in your eye that you're going closer to it. How does it work in PC? That's pixels. That's just digital zoom. Is this fine? Is there anything? Does that clarify? I know you'll have to sit and think with this. You have to sit there, look at the mirror, convince yourself. Try that experiment at least. Take a candle, keep it at 2f, see the object, try to see the object. So if you stand with Nidhi, okay, if I stand with Nidhi, Nidhi will be infinitely big in my eye. She's right next to me. Okay. Obviously, she'll be infinitely big in the retina. Agree with that? If you're right next to Nidhi, she'll appear like crazy big to you. But the Nidhi in the mirror will be much smaller. Because let's say you're standing right next, let's say very close, somewhere here. Let's say this is Anvita standing next immediately, and this is Nidhi here. Then in your eye, Nidhi makes a very huge, leave her entire body, just look at the face. The face itself covers a lot of your portion of your retina. Okay, it might cover entire retina actually, just her face if you're standing that close. So all you will see is Nidhi's face, not even the background. If you go close to someone that close, you won't even see anything in the background. You'll just see their face. Got that? And if you say hut and remove Nidhi, you'll see an image in the retina, image in the mirror, which will be smaller because Nidhi has gone far away from you now. The image of Nidhi has gone far away from you. So what you see is that. Is that fine? Did you guys get it, Nidhi and Anvita, both of you, whoever asked those series of questions? Okay. Anything else? I'm just trying to, you have to experiment a lot. Can you explain the graph of the electrons? That graph is not explainable. That's going to take time, but okay, I'll just tell you what it is. Okay. So there was a question about what was that graph earlier that you saw, the potential varying across the battery and this thing. So there was a graph that went like this. It went like this, and then I think this is a graph, right? I'm just brushing up. I'll come to that, Nidhi. 1 second. I'll just finish this part. Hope you can wait if you're not getting late. So there was this resistor part where again the voltage went like this and then dropped again, went off. Now, what I was trying to tell you is, in a circuit, if you have a battery and if you have, let's say, a resistor and then like this, the potential initially will be 0 at this end. Okay, when you go to the other side, it rises. This is the battery. This section is the battery. Okay, this is the battery, and the voltage rises suddenly. The voltage becomes roughly about, let's say, 18 volts if the battery is 18 volts. Is this part fine? And then it remains the same throughout the wire. It's 18 volts, 18 volts, 18 volts, 18 volts, 18 volts, till the resistor. At the resistor, what happens? Drops. So the potential drops to roughly about 0. So in a simple case, in a wire, by the way, in a wire, it remains the same. In a wire section, it remains the same. Inside the resistor, it drops. This is the resistor section. Wire, this is the wire. And again, inside the wire, it remains a constant, 0 volts. That's the explanation. Is that fine? Okay. When I was playing around with my convex lens, the image at one point became crazy large, like really magnified. Why is this? Is the image formed on the retina infinitely large? Yeah, this was a blur part 2 discussion. I never gave an answer to that. Why does the image get blurry and get magnified? Okay, I just want to, okay, what are you doing right now, Nidhi? Are you taking the magnifying lens and doing this? I think this is what you're doing, okay? My best guess is this. I'll turn on the video cam. I think this might work. Hoping that this will work. I think you did this. Can you see this thing? Can I get yes on that? Can you see the, 1 second? I don't know, I'm trying to keep this thing. Can you see the pen here? Can you see the pen? Can you see the pen? Yeah. As I take it further and further away, 1 second. You see the object gets crazy magnified. Can you see that pen gets crazy magnified? Yeah, that's exactly what you're talking about, right? You're talking about that, right? That's exactly what you're talking about, right? I'll have to switch the audio just to keep my bandwidth low. 1 second. Yeah, that's okay. That's the question I was asking in Blur 2. Is it infinitely magnified? That's the first question. Is the pen actually infinitely magnified? In my childhood, I used to think that itself. I used to think, not childhood, For a very long time, I thought it is getting infinitely magnified. Then I realized it's actually not getting infinitely magnified, to my surprise. It's actually not infinite magnification. One more hint, one more clue for you. It gets blurry even before it gets magnified. It gets blurry before that. That's the question I was asking in blur part 2. Why does it get blurry? Okay. And do you have any hints, guesses of why that happens, or should I explain? I can explain. I have the answer. I figured it out. That was the main part of the discussion, blurred part 2. I never mentioned it or never answered to that question. I didn't saw the blur part 2 part. Because it forms a near point. Okay, I'll explain. Fine. It's not. Navya is asking me to explain. It forms near point. Yeah, something to do with the near point. I told you, right? The way to solve this problem is start with something that you already know. What do you know? If you have a magnifying lens placed in front of your eye, and this is your eye, let's say, and there'll be a near point where it gets, well, normally it would get blurry. There'll be a new near point created. Okay, that's called, let's call it new near point ND. Is that fine? So do you remember this? Oh, you can't see the screen. I'm not shared it. I've shared it. Can you see it now? We can't see the screen. Can you guys see the screen? Nidhi, now can you see the screen? Just tell me, can you see the screens? Yeah. Okay, Nidhi can't see it since anyways, but I hope this is fine. This part is fine. Yeah, okay. Hope this part is fine. The near point gets closer. Now let's say this is a focal length of the lens. Remember this diagram long back? I told you. Everything here will be what? Blurry? Agree with that? Agree with that? Inside the magnifying lens will be blurry beyond that point. Here it will be clear. Remember this? Clear. The new near point, till the new near point will be clear. Here again it's blurry. Remember this? Yes. Now here's your secret answer, okay? Here's the answer. When the eye is closer, that's what happens. When you take the eye away, what happens? What did I tell you? The image gets magnified, right? The image still gets magnified because if you look at it, if you're looking at the object here, if you're keeping the object here, let's say you're taking it to the focus, the image is here, you can clearly see it. Okay, so directly if you see, it will be this size, this will be the size of the image. But when you take, let's say directly if you're saying this is the object, let's say, I'm going to call this the object. Its image will be formed beyond, agree with that, further and further away. It'll be formed somewhere here. Agree with that? Making the same angle with the lens, but with your eye, it went from less than 5 degrees to roughly about how much now? If your eye was at the lens, you know, it would have remained the same. Now, how much did it become roughly? 5 degrees, it might have gone to about 15 degrees. Do you get that? Okay, now understand this. If your eye was further and further away, agree that this angle would be roughly about, let's say, 1 degree, and your angular size would have reached about roughly about, let's say, 15 degrees. Fine with that? The image is now 15 times magnified in your eye. Okay, now understand this. The reason why you're getting that high magnification is because you're starting off with a very small angle in the first case itself. It's not like you have, what do you say, the magnifying lens is doing some great job of getting a big image. It's not magnifying at all, actually. From that distance that you are, it's already so small, 1 degree, which you could have got a large angle if you had gone closer. Okay, now what will happen if I take this object and bring it close to the focus? What will happen? At the focus, almost at the focus, where will the image be formed? This image. Where will the image be formed? Agree that it will be formed almost at infinity. When you keep the object at the focus, when you read the focus, it will form really, really far. So do you agree this will converge eventually? This angle that it makes with you will converge to something like about 15 to 20 degrees. It won't go greater than that. So no matter how far you go, when you read the focus, it will read the highest magnification it can. It will go from 1 degree to 20 degrees maximum. Okay, now if you don't believe this, I did not believe this part. So I made a Desmos application just to convince myself. and it's here, it's lying around somewhere here. I did it just to convince myself that is true. I think the eye calculation explaining blur, yeah, this is. So if you look at it now, let's say this is the eye and it's near point. Can you, okay, can you see it? Can I get yes or no? Yeah. Now observe this. What happens as I bring the object almost close to the focus? What happens? As I take the object to the, this is what you're doing with your lens, right? This is what you're exactly doing with the magnifying glass. You're saying the image gets magnified like crazy large. So look what happens. What happens? I'm going from, observe, okay, I'll tell you one more thing. The angle initially is 10 degrees now. Okay, the object is making 10 degrees with your eye. Okay, just making 10 degrees. This angle here which you're seeing is just 10 degrees. I hope I can hit the projector mode I'm seeing. This angle is roughly about just 10 degrees. Now, as I bring it closer and closer, look at the angle, it becomes 11 degrees, it increases. But image angle is now 26 degrees, so it appears magnified. That part is clear? Can I get a yes or no? Yeah. Now watch what happens as I take the object closer and closer. Look at the magnification, look at the magnification. It's 2 now. Magnification is 2. It went from 11 to 28. Observe as I go closer and closer to this thing. Object goes to almost to infinity. It reaches a maximum magnification of just 3.2. It doesn't go beyond that. Got that? It converges. You can't get a magnification higher than that. So you won't get infinitely magnified object. What you're getting is there's a highest magnification you'll reach. And second thing, that image gets blurrier as you go further and further away because you've gone beyond the focal point of this thing. I told you, right? Beyond the focal point, things are blurry anyways. The image goes, once it goes beyond the focal point, it's anyways blurry. Because we have learned that when we kept the eye very close to the magnifying lens already. Is this convincing? I might be confusing, but just saying. So, okay, I played with the recto. I got the lens. One second. I got the lens. Okay. To focus the image, focus the image at the focus of the minimum f. Okay, then as the image is formed at f of the eye, won't the image be at infinity on the retina? Okay, 1 second. So I played with it. So I got the lens to focus the image at the focus of the minimum f of the eye. Okay, you're getting into the near point. That's what you're saying, right? Can I get a yes or no on that? Can I get a yes or no? Nidhi, what you said? I got the lens. Can you share your screen at least? Is that possible? I'll let you share the screen, but if you have that option, if you can, I am allowing you to share your screen now. Can you share the screen? I'll stop my share if you want. Okay. Just hit share screen. I'll get an idea. Okay, 1 sec. Okay, I'll wait. I know, but the problem is our microphone is not working. Actually, I'm planning on developing an applet so people can understand what I mean by that. Like, how does the image actually look, and when you take the object, magnifying lens closer, further away, how those things change. I don't have the time these days, so otherwise I would have finished it, but sorry. Okay, Nidhi, you're there? 2 seconds, okay, fine. So far was 1 second. You asked me for 1 second, so I know what 2 seconds feel like now. Okay, time has slowed down for her. Have you heard of Elon Musk time? It's a unit of time. 1 Elon is said to be, if he promises that he'll build a rocket within 10 years, Elon Musk takes about double the amount. So Okay, nice. This is good. Okay, so you placed, let me get this right. Where's the chat now? And I need it. Okay. Okay, I'm seeing a screen now. Okay, so you've kept the object there and the focal length, and yes, the image is formed is very small here. By the way, can you give a height to it? Can you give a height to it? Can you raise the object slightly from that line so that it gets some height? Otherwise, it will not. We can't even compare the heights otherwise. Can you increase the height slightly? Height of the object, height of the object. So you increase, take the source a little higher, take the source a little higher. Let's say take it about 1 centimeters higher from the axis, that you've drawn, the scale that you've drawn. Can you do that? Hello? Yeah, you've done it. Okay. Okay, now let's see things. Can you turn on extended rays? Extended rays? Extended rays. Can you turn on extended rays? Uh-oh, that's really, really far. Okay, fine. So if you look at it now, I think this is, I'm not wrong here. The image is formed roughly here. Image is formed roughly here, somewhere at, I think you can annotate in a screen. So one second, I'll draw on your screen. Damn it, I can't annotate. 1 second, okay. So the image is formed roughly, but I can't even see those numbers. But it's formed somewhere. You can see the first image form, right? Can I get a yes on that, everyone? Others also, whoever, even you. That's where the image is formed. Yeah. Now, can you tell me what you've done Nidhi, exactly? Why have we placed, this is the eye lens you're talking about, the second one, I believe. So the object is between F and O, okay, of the convex lens. So it will form, it is not forming a virtual image then of the convex lens of the eye or the other lens which you have. It's forming a real image here. In the first lens is forming a real image, so it should be beyond F. You've gone beyond F. Okay, you kept it beyond F. Then I told you, yes, the image will be formed really, really far. A real image will be formed. Now you're trying to view that real image, let's say. Okay. When you try to see that real image, what will happen? The eye lens will adjust to see that image. Agree with that? The image formed at F of the eye lens. Okay, got it. So if you place the object at the F of the eye lens, yeah, so you'll see the object, nothing big deal here. You will end up seeing, if I'm not wrong, something is wrong with this diagram. Can you tweak it slightly so that it's not at the focus? Can you slightly tweak the object slightly so that it's not at the focus? Take it, I think you have to take it back, take it back. Take it further from the lens, more away from F. Little bit more away from the F. Just push it away from the F, the object. Push it further away. Object further away, object. Oh, don't press, don't do that. It's fine, it'll work. Just take the source and push it away. Can you zoom back? Okay, can you give control to your screen for me? I don't think I can request that. Anyways, so sorry, don't. Just push it for now. Just push it away. Okay. Okay, do you understand what's happening here now? The first image is formed here. The first image is formed somewhere there. I can't annotate on your screen. I think this is my problem. I'll have to do it. One second. I'll change some settings. I'll be able to do that. Okay. Security. I can't do that. Okay. I don't think I have that option. Sorry, I can't do that. I can't annotate. I link the sim. Okay. I think I'll play around with this, but I think I got an idea. So you're forming an image here at around between the lens. You form the first image, and the eye lens is trying to pick that up. Okay, the eye lens will try to pick it up. Now the question is, yeah, this looks like, yeah, it forms an image behind the retina. Can you see that? Can you see it has formed the image behind the retina? Yeah, but it can't converge anymore. That's why it appears blurry. Yes, in some sense, what's happened is this time we've gone beyond. If you go beyond this thing, I told you, right? If you go beyond F, the image is formed beyond the retina. The question is, why does it get blurry when you take it to the focus and beyond? And if you take it beyond the focus, it will anyhow appear blurry because the image is formed beyond your retina, behind your retina. That too. Okay, it's way closer than your near point. If see, for the eye to focus, things have to be away from your near point, but this is like it's formed behind you. Is that fine, Nidhi? Yeah. Okay. Just tweak it. You'll get an idea. When you read the focus, the eye can't focus no matter what. I wanted to build a simulator where eye wouldn't matter, because the problem is we are taking the. See, I'll tell you in the simplest sense. Yeah, this is the answer to the blur part too. Why does it get blurred when you take it beyond a certain, when it almost reaches the focus, it gets blurry, right? So why was that? Turns out it doesn't get infinitely magnified. It actually, what happens is it reaches a certain magnification, but it gets blurry because at the focus, almost it goes beyond the focus or reaches the focus. The image is formed where it's formed, earlier it was formed at infinity. A normal person could see it, but now it's formed behind your retina. So it's way closer to your near point, so you can't see it. That's the reason. That's the same reason which you told earlier works here also for the blur part too. So, okay. Just experiment with it. You'll get a rough idea. If nothing works out, just call me. I think we can talk about it. But I think this should be fine. Is this fine? Does anybody else have a doubt? Thank you for staying back, all of you. Okay, fine. It's fine. It's fine. The Zoom share is fine. Okay. So that's about it. Does anybody have anything to say? This was too long. Yeah. Satvika, thanks, Nidhi, by the way, just saying. Yeah, thank you. You're welcome. Yeah. Okay, so bye-bye, guys. Take care. And yeah, then. Take care. I think that worked. Yeah. Okay, Elon Musk time, maybe. I don't know. Let's see. We'll look into that. Yeah. Okay, then. Bye-bye. Take care. This will take some time.